Hello there, and welcome to Sleep Science. I'm so glad you found your way here. Let the room grow quieter by a shade or two. Edges blur. The air takes on that velvety hush that belongs only to night. If you wish, dim the lights until the world feels gentler than it did a moment ago. Place your hands somewhere they don't have to hold anything. Unclench the tiny muscles around your eyes. Loosen your jaw. Let your tongue rest broad and easy. Breathe in, slowly, feeling the cool touch at the tip of your nose. And breathe out even more slowly, like a wave folding itself into dark sand. Again inhale, 2, 3. Exhale, 2, 3. Each breath a small erasure, the day receding like footsteps down a hallway. Tonight, we'll drift through questions science has not yet solved. 50 of them, each a doorway to wonder. Some live far away, in the silence between galaxies, at the trembling rims of black holes, across the woven fabric of space-time. Others are close, in the chemistry of our cells, in the weather of this planet, in the secret theatre of the mind that dreams while you sleep. We are not here to force conclusions. We are here to let curiosity become weightless. We will hold each mystery as you would hold a smooth river stone, not to grasp, but to feel. Think of sleep science as a quiet companion, walking a step ahead with a lantern, not a lecturer reciting facts, not a preacher proclaiming certainty, just a kind, unhurried guide. The voice you hear will never push you upward, it will help you float. Where most stories climb toward noise and brass, we move like the tide. A calmer question, a small shimmer of surprise, a settling, a deeper calm. Each wave glides into the next, until your breath discovers its own slow rhythm. Listen closely. There's a chorus gentler than silence in this very room. The whir of a distant fan, a car finishing its errands beneath the window, the faint rustle of fabric as your chest rises and falls. The pillow smells of sunlight. The blanket carries patient warmth. Outside, the sky is ink blue. The stars are not shouting, only shining, steady as old friends. Imagine their light, crossing impossible distances, arriving here as a lullaby. Science is our lantern, yes, but every lantern casts a shadow, and in those shadows, the world remains unfinished. We celebrate what we know, equations that fit, instruments that catch the whisper of particles, telescopes that look back almost to the first dawn. Yet, the honest story of science also holds closed doors, hallways that turn into darkness, labels that read unknown. That is not failure, that is invitation. Tonight, we accept it, unhurried, with the gentlest awe. Picture a quiet lake beneath the night. The surface is smooth as glass, holding a reflection of the Milky Way. Silver dust floating on black water. We will drop 50 pebbles, one by one. Each pebble a question. Why does anything exist? What is time made of? How did life begin? Why do dreams arrive unbidden? Where does the ocean keep its first memory? With every drop, ripples widen and fade, and the lake remains patient, ready for the next pebble, making no sound. Breathe in, a little deeper this time. Breathe out, let your shoulders fall. If your eyelids grow heavy, let them. If your thoughts loosen and drift, let them. You don't have to steer every sentence. The words will carry you, like a slow current carrying a leaf, held, unspun, unlost. There is nothing to solve now, no test to pass, no argument to win. The unknown is no longer a cliff. It is a cushion, a soft chamber where the mind may rest and still feel alive. We will visit these mysteries the way one visits ancient trees at night, touching the bark, listening for sap, leaving the roots undisturbed, a small note for comfort. You will see no faces on the screen. This is a faceless journey, only voice, close and kind. Soundscapes that breathe, music gentle enough to vanish. The goal is not to keep you awake with questions, but to let the questions keep you safe while you drift. If sleep comes, let it come. You can always return later. The mysteries will wait without impatience. As we move through our 50 scenes, we'll treat each as a tiny constellation, beginning with vast canvases, the birth of everything, the arrow of time, the invisible threads binding galaxies. Then we'll draw closer to Earth, to storms and stone, to oceans under frozen moons, to lives that outlast centuries. Finally, we'll come home to the intimate. Memory, emotion, music, love, the private starfields within the human mind. If you'd like a rhythm to travel by, keep this count beside you. Inhale, 2, 3, 4. Exhale, 2, 3, 4. Each number is a soft footfall on a wooden bridge at dusk. The water below drifts slowly. The world is kind. Curiosity doesn't press, it glows. And now, with the room at ease and your body a little heavier in the best possible way, we'll approach the first door. We won't knock loudly. We'll simply rest a palm against the wood and feel the hum on the other side. Imagine a room so quiet you can hear the soft click of your own blinking. Now, imagine a quiet beyond that, no air, no dust, no space to hold the silence. Philosophers call it nothing, yet in physics, true nothingness is slippery. Even the vacuum, when we strip it of matter and light, trembles with possibility. Fields fluctuating, pairs of ghost particles flickering into being and vanishing again, like tiny fish darting just beneath black water. If nothing is unstably, perhaps something is what naturally happens, like a pencil that cannot balance upright forever and must tip. Some cosmologists picture a vast landscape of possible realities, a multiverse in which universes bud off the way bubbles rise through boiling water, each with its own physical rules. It's a bold idea, and it might soften the shock of our improbable existence, but it doesn't answer why the whole pot exists, why there is any water to boil. Others suggest that existence is the default, that non-existence is logically impossible. Reality, in some form, must always be. It's a thought that hums like a low organ note felt in the ribs, hard to analyze. The trouble is testability. No telescope can look before being. No collider can press its finger on the first yes of the cosmos. So we circle the question softly. Perhaps laws are prior to the world. Perhaps worlds condense from law the way frost condenses from cold air. Or perhaps laws themselves are emergent, rising with the universe like rules in a growing game. For now, we rest in wonder. On your next breath, let the question be light and cool, not sharp, more a smooth river stone than a blade. If something must exist, we are inside that must. If not, we are inside the most delicate accident. Either way, the marvel holds. And as you exhale, feel the room around you, the simple fact of here. That alone is a lantern, and its circle of light is wide enough to carry us to the next door. Picture a fabric drawn tight, then released in a sudden bloom, space itself stretching, every thread moving away from every other thread. We can read the afterglow of that beginning in the cosmic microwave background, a faint warm whisper bathing all directions. We can measure the universe's age, chart how galaxies formed from tiny ripples, infer that in the first breath of time, something called inflation may have driven an almost impossibly rapid expansion. But the match that struck the kindling remains unseen. Was the Big Bang a quantum tremor, a fluctuation in a field with no outside, where time and space themselves were born in the same heartbeat? If time began there, before, maybe the wrong shape of word, like asking what's north of the North Pole. Some imagine cycles, universes that expand and cool, then crunch and rebound, an endless pulse, too slow for any one cosmos to notice. Others explore bouncing models where a prior contraction softly reverses, trading collapse for growth. There are proposals in which our Big Bang is the collision of higher dimensional membranes, brains brushing like two silk curtains in a dark hall, their touch becoming everything we know. Each picture solves certain puzzles and leaves others in shadow, and the first instant stays behind an event curtain that no light can traverse. If inflation happened, what field drove it? Why did it start, and why did it stop so precisely that galaxies had room to form? We sharpen instruments, launch new observatories, listen for faint swirls in ancient light that might be inflation's fingerprints. Meanwhile, breathe steadily in and out, letting the mind rest where certainty is not required. The story of the cosmos opens convincingly at fractions of a second, yet the spark is still a secret. We will approach it again and again, like a shoreline visited at different tides, and each time the water will have moved, inviting us onward. Hold a warm mug, feel heat drift into your hands. Set it down, and the warmth spreads into the room. You never watch the whole process reverse. The air does not gather its scattered heat and slip it back into the cup. This everyday truth is the arrow of time. Microscopically, though, the equations that guide particles don't insist on a direction. Run them forward or backward, and they still behave perfectly polite, perfectly symmetric. Somewhere between the reversible dance of atoms and the irreversible hush of a cooling cup, an arrow appears. One story points to entropy, the measure of how many ways a system can be arranged without changing what you notice. The early universe, for reasons we don't yet grasp, seems to have started in an extraordinarily ordered state, like a deck of cards arranged by suit and rank. From such low entropy, there is overwhelmingly more room to wander than to restack, so time's river finds a downhill. Another story ties the arrow to the spread of information, how records are written into the world, how traces accumulate but rarely unaccumulate. A broken glass leaves shards and memory. An unbroken glass leaves no shards to collect themselves. Still others wonder whether the arrow is stitched to cosmic expansion. As space grows, so do the possible arrangements, and the future simply has more places to be than the past. Yet none of these accounts feels final. Why that initial order? Why do we remember yesterday, but not tomorrow? Why do living things seem to push against the tide, locally building structure, weaving order, while globally the tide keeps rising as you breathe? Notice your own inner arrow, the inhale arriving, the exhale leaving, the soft wake of moments dissolving behind you. Time's direction is the frame for every memory, every plan, every lullaby. We dwell inside it the way fish dwell in water, rarely seeing the medium itself. Let the question float without urgency. Perhaps the arrow is the universe's gentlest law, not commanded but chosen by the weight of possibilities. And with that, we can set the mug down, watch a curl of steam vanish, and step quietly toward mystery number 4. Imagine a spiral galaxy turning in the night, its arms threaded with blue-white stars and dusty lanes. If you could sit on the rim and watch, you'd expect the far-out stars to drift more slowly, the way planets move more slowly the farther they are from the sun. But they don't. They race too fast, as if an invisible hand were holding everything together. Across the cosmos, that same unseen grip shows up again and again, an extra gravity that light cannot reveal. We trace its outlines by the way it bends starlight, like glass warping a view. Entire clusters of galaxies act as natural lenses, magnifying background objects in arcs and rings. The large-scale map of the universe, the filaments and knots of the cosmic web, also hints at a hidden scaffolding shaping where galaxies can grow. Everywhere we look, the math points to a vast reservoir of mass, that neither glows nor absorbs, dark matter. What could it be? Some imagine undiscovered particles that barely touch ordinary atoms, WIMPs that pass through a light year of lead without a brush, or whisper-light axions rippling like a field across space. Others wonder about sterile neutrinos, shy cousins of the ghostly particles streaming from the sun. A different possibility skips particles altogether, ancient black holes, born in the first instance after the Big Bang, so small and so dark we'd only feel their pull. Deep underground, detectors wait in patient silence for a single knock, one dark particle tapping a nucleus. On mountain tops and in space, telescopes search for faint signs of annihilation or decay. Colliders sift high-energy collisions for footprints that standard physics cannot explain. And yet, the room stays quiet. Perhaps our quarry is lighter, stranger, more collective than we thought. Perhaps gravity itself changes in subtle ways at vast scales. For now, dark matter remains a gentle pressure felt but not seen, a cloak 5 times heavier than everything we can name. If you listen closely, you can almost hear the hush of its presence, the soft tension holding spirals intact, the invisible music keeping stars in step. Let that quiet weight be comforting. The universe carries more than it shows, and what it carries helps everything hold together. On your next slow breath, we can turn toward the force that does not hold but pushes the mystery of dark energy. In the late 1992, astronomers watched dying stars in faraway galaxies as if they were cosmic beacons. Those supernovae should have revealed a slowing universe, gravity tugging gently on everything, easing the expansion over time. Instead, a softer shock arrived. The expansion is speeding up. Galaxies aren't just drifting apart, they're drifting apart faster and faster, as though empty space were laced with an outward pressure. We gave the phenomenon a placeholder name, dark energy. It doesn't shine, but its effects add up across immensity until they reshape fate. Roughly 7 parts in 10 of the cosmos seem to be this mysterious something, with matter ordinary and dark making up the rest. One idea revives Einstein's cosmological constant. Vacuum itself carries a steady energy, the same everywhere, everywhen, a kind of faint elastic built into the fabric of space-time. Another idea lets that energy change with time, a dynamic field, quintessence, that ebbs and flows. A third possibility whispers that our understanding of gravity is incomplete on the grandest scales, and what we call dark energy is the shadow of a deeper rule. We listen for clues in multiple keys, the pattern of ancient sound waves frozen into the distribution of galaxies, the subtle way clusters grow, the delicate flicker of that baby universe afterglow. Each measurement narrows the options, like tightening the weave of a net. Still, the catch slips through. If dark energy is truly constant, space will keep widening and thinning, galaxies will dim from each other's view, and the night will grow lonelier. If it strengthens with time, a big rip could, far in the future, unbind even atoms. If it weakens, gravity may one day reclaim the stage with a slow hush. For now, we rock gently in a universe whose future depends on a quiet pressure we cannot bottle or see. Imagine us standing on a wide plain under a big sky, feeling a wind so soft you cannot feel it on your skin, only on the grass around you. That is dark energy, the wind in the grass of space. Breathe in, notice the stillness in your room. Breathe out, let the horizon widen. Ahead waits a subtler riddle, not the push or pull of the cosmos, but the uncanny rightness of its settings, why the dials seem tuned for life. Hold the idea of a control panel, dozens of sliders, labeled with the constants of nature, the strength of gravity, the charge of the electron, the masses of quarks, the speed of light. Nudge many of them even slightly, and the stage collapses. With stronger gravity, stars might burn too fast, collapsing before chemistry can weave complexity. With weaker gravity, matter could drift too loosely to form galaxies at all. If the electromagnetic force were a touch different, atoms might not bind. If certain nuclear resonances shifted, stars couldn't forge carbon, the backbone of our biology. It's as though the orchestra were tuned to a narrow band where melody is possible. What story explains this fine-tuning? One is the simplest coincidence, though that word does little to soothe wonder. Another is the multiverse, a vast variety of universes, each with different settings, bubbling into being like foam on the sea. In most, nothing like life arises. In a few, matter organizes, stars shine, and observers eventually ask questions. This is the selection effect. Of course, we find ourselves in a life-friendly universe. Where else could we be? A third possibility is deeper still, that some fundamental principle, not yet discovered, pins the sliders where they are. The laws might be the only self-consistent solution, or the byproduct of symmetries broken in just the right way. Each story comforts and discomforts in turn. The multiverse spreads explanation thin across unseeable worlds. Coincidence feels like a shrug. A hidden principle invites a long search down quiet corridors of theory and experiment. Perhaps the truth is a braid, a lawful structure that still allows variety, with our branch lucky enough to sing. Perhaps we've misread the panel. Perhaps life itself is more adaptable than we imagine, able to bloom under different rules we would still call life. For tonight, let the puzzle sit beside you like a closed book with a beautiful cover. You do not need to open it to feel its weight. The cosmos may be rare, or it may be inevitable. Either way, you are here breathing, listening, a small and necessary ear inside the grand composition. As your breath settles, notice how the thought softens. Not an alarm bell, but a lullaby. When you're ready, we can step to the next door and lean into the dark to ask how big the stage really is and whether it ends anywhere at all. Imagine standing under a night so clear the Milky Way looks like weather silver clouds flowing from horizon to horizon. Now expand your view until even galaxies become dust motes in a flood of darkness. Our observable universe is a sphere centered on us only by accident. Its radius is set by the time light has had to reach us since the first dawn. That bubble spans roughly 90 billion light-years across, a number that feels like a myth more than a measurement. But beyond the bubble, the stage may go on without curtain or wall. Cosmic cartography is subtle. We read geometry from the oldest light, the cosmic microwave background, like surveyors testing whether the ground is flat or curved. Its mottled pattern, frozen from infant sound waves, tells us space is very nearly flat on the largest scales we can see. Flat suggests parallel lines, stay parallel, triangles sum to neat, Euclidean angles. Yet, nearly leaves a soft H of possibility, a grand curvature too gentle for our horizon to reveal. Space could be finite but unbounded, like the surface of a sphere sail straight long enough and you return from behind. Or it could be infinite, an ocean with no shore, where any finite map is only a child's drawing in the sand. And size intertwines with topology, the way space is stitched. Even a flat universe might wrap in hidden ways. A three-dimensional hall of mirrors, where light, after a very long voyage, re-enters from another side, painting ghostly repetitions of distant structures. We hunt for such echoes, matched circles in ancient light, repeated patterns in the deep arrangement of galaxies. So far, the sky keeps a straight face. If the universe is finite, its volume may dwarf imagination, yet still be countable in principle. If infinite, then almost every motif occurs somewhere. Spiral galaxies like ours, and stranger shapes we'll never name. Either way, the question is a pillow, not a cliff. You can rest your head on the mystery and feel it support you. space that might loop like a lullaby or sprawl like a calm seer at night. Breathe in, picture the grid of stars thinning toward forever. Breathe out, and let the edge, real or imagined, dissolve into dark tenderness. We turn now to a boundary more intimate than shape, the moving horizon that forever hides most of everything. When you look at a distant galaxy, you are reading old mail light posted billions of years ago, finally touched by your eyes. Push farther, and you reach a limit not of courage, but of time, a cosmic horizon. It isn't a wall, it's a so far and no farther yet, set by how long the universe has been carrying light to us. Beyond it, reality continues, indifferent to our reach. Stars form and die. Perhaps planets wake, perhaps minds wander, but their letters will never arrive. This hidden majority is not exotic by decree, it is simply elsewhere. Still, inflation, the early rush that may have blown space wide, suggests an even deeper seclusion. In many versions, our observable patch is a small, smooth bubble carved out from an immensely larger quilt. Neighboring regions, forever beyond our light cone, may carry different arrangements of the same ingredients, or even slightly different cosmic weathers, variations in density, in curvature, in the delicate seeds from which clusters grow. Some models go bolder, imagining domains where the rules themselves tilt constants shifted, particles arranged under different symmetries, though such speculation tiptoes along the border of testability. What can be known about what cannot be seen? We read edges for hints. The spectrum of the microwave background, so uniform it feels like a lullaby, tells us our patch is ordinary, in a good way. The distribution of galaxies, their slow foam of filaments and voids, matches what simple beginnings would yield over time. No obvious fingerprints of a neighbor press through our sky. No repeated motifs circle back to betray a wraparound. The hidden remains hidden and yet not hostile. It's the rest of the book we haven't unbound, pages still stitched. Let that admission be gentle. Most of the universe will never meet us. That is not tragedy, it's a kind of mercy. We have enough night to learn our small region well, to tend our tiny fire, to listen for faint messages in the radiation rain. As you breathe, imagine the horizon not as a border, but as a soft shoreline at dusk, waves arriving from far beyond your sight. They break in a rhythm old as the world, and ask nothing of you but to listen. And somewhere past those waves, perhaps other shores, other evenings, other listeners, hold a foam of bubbles in your hands, each sphere thin and gleaming, each reflecting a warped room. Now imagine the foam as reality writ vast, domains budding from inflation, like bubbles in a quantum pot. String theory's landscape offering valleys where different physics settle, branching interpretations of quantum measurement where possibilities diverge and never rejoin. The word multiverse gathers many such ideas under one soft umbrella, each addressing puzzles that single universe stories strain to bear the fine-tuning of constants, the first shove of creation, the probabilistic whispers of quantum events. There is grace here. If countless universes exist with varied settings, then it's no surprise we wake in a hospitable one. The selection effect becomes a quiet explanation, fish marveling that water fits them so well. But grace is not proof. If other universes sit forever beyond our causal reach, the multiverse risks becoming a mirror you cannot breathe on, elegant, reflective, untouchable. Scientists look for leakage, imprints our neighbors might have left, a subtle bruise in the cosmic microwave background from an ancient bubble collision, statistical oddities in how structures cluster, deviations that say our patch is part of something more. So far, the sky is calm. The hints, when they appear, arrive as whispers and evaporate under closer listening. Another strand of multiverse thinking is quieter still, the many worlds path of quantum theory, where a measurement does not choose one outcome but fans into branches, each outcome real, in its own world, with interference gone like fog burned off by noon. In that vision, the multiverse doesn't sprawl in distant space. It unfolds in possibility space, right under the floorboards of every moment. It is both intimate and vertiginous, every coin toss a spray of timelines, every lullaby sung across a thicket of near-identical nights. Whether these visions describe reality or only our reach for it, they share a mood, the sense that universe may be too small a word. Let that wideness be soothing, not dizzying. If there are many rooms in Cosmic House, we only need to make ours gentle and awake. Breathe in, feel the breath. Breathe out, keep only the calm. Should the multiverse exist, it cradles us without asking for our recognition. Should it not, this single universe is already more than enough vast, articulate, and full of questions. And with that thought, settling like quiet dust in lamplight, we step to the next door. The fabric itself, what space and time are made of. Imagine laying your hand on a drumhead in the dark. You can't see the membrane, but you can feel its give, its quiet tension, the way a fingertip sends ripples outward. Einstein taught us to think of gravity not as a pull from faraway masses, but as curves in a fabric, space and time joined as one surface, bending around stars and planets the way that drumhead sags beneath a stone. Light follows the contours, clocks tick at different rates depending on altitude and acceleration, and the cosmos becomes less like empty stage and more like living cloth. Yet, when we lean closer than any microscope can see, the story blurs. Quantum theory says the world at small scales is never truly still. Uncertainty is a tremble built into being. If everything else flickers, should space-time flicker too? Many suspect it does, a froth at the Planck scale. Distance is so tiny that words like before and after, here and there, begin to lose their grip. Some proposals imagine geometry emerging from entanglement, as if space were the tapestry and quantum links were the threads. Stitch enough correlations between tiny systems and you weave a shape, a distance, a bridge. Others picture loops, finite rings of area and volume clicking together, like beads to build a continuum we only feel as smooth. There are approaches that trade geometry for information, suggesting that what we call space-time is the long, slow shadow of computation, humming underneath reality. We search for hints the way sailors listen for depth, gravitational waves murmuring from colliding black holes, gamma-ray bursts arriving without the expected dispersion that a grainy space might cause. The tiny variations in primordial light that could betray an origin in discrete building blocks. So far, the fabric feels seamless to every test we've devised, but seamless to our touch does not mean unstitched. A silk scarf looks continuous even though it is threads. Breathe in and think of the floor under your bed, steady, supportive, unnoticed when you're most at ease. Breathe out and let the question loosen. If space-time has atoms, they are quiet ones, too soft for daily senses, too small for our largest machines. We'll meet them perhaps when a single language finally speaks both gravity and quanta at once. Until then, rest in the kindness of the fabric we have and the patience of the loom we have yet to find. Picture a narrow slit of moonlight falling across the floor. Now imagine sending an electron through a pair of slits toward a screen. If you open just one path, the arrivals paint a tidy band. Open both, and the pattern becomes a set of light and dark stripes, the signature of interference, as if the electron were a wave exploring both doors and overlapping with itself. But send the particles one at a time, tap, 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 and the stripes still grow from individual dots. Each electron lands in a single spot. Yet the ensemble reveals a wave that sampled both ways. Ask which slit it used, install a detector, and the stripes dissolve into two simple bands, as though the question itself closed one of the possibilities. This is superposition, the rules that let a quantum object exist as a combination of alternatives until interaction with the world forces a decision. We've seen it not only with electrons, but with entire molecules made of dozens, even thousands of atoms, fragile waves, held together in carefully isolated experiments, vanishing if hosted by air, light, or heat. The mathematics is clear and reliable. It powers lasers, MRE machines, and the first delicate steps of quantum computing. What it means is harder to cradle. One reading says the wave function is a tool for prediction only, a book of odds that collapses to a single story when measurement writes ink on the page. Another says the wave is as real as rain, and measurement is just entanglement with a bigger system, no collapse, only branches. Here the particle chooses the left slit, there it chooses the right. The world splits softly, invisibly, keeping all outcomes. Others imagine hidden variables steering what we cannot see, or modifications to the equations that make collapse a physical event, a gentle snap, rather than a bookkeeping trick. Each picture comforts one itch and worsens another. As you breathe, let the paradox soften. You don't have to choose a camp tonight. Superposition is not an alarm. It is a lullaby in the key of both and, reminding us that certainty is a late addition to things, arriving only when we touch. Before touch, the world is generous with options. After, it is precise. Between those two, there is a hush where wonder thrives. Take 2 coins, polish them until they mirror the room, and press them together. In the quantum world, that touch can create entanglement, a link so deep that measuring one coin's face instantly tells you the others, no matter how far apart they fly. Not a signal darting through space, not a secret wire, but correlations written at the moment of creation, persisting even when oceans or light years lie between. Einstein called it spooky action at a distance, and for decades, many hoped a hidden script, unknown variables tucked under the table might explain the eeriness. But the universe had other ideas. Experiments that test Bell's inequalities close loophole after loophole, showing that no model with local, pre-written instructions can reproduce the full strength of quantum correlations. The world is either non-locale in a very specific, subtle sense, or our notion of properties existing before measurement must be revised. Meanwhile, entanglement has moved from philosophy to technology, quantum key distribution that can reveal eavesdropping by the slightest disturbance, teleportation of quantum states, not matter, but information about a system between lab benches and across city fibers, prototypes of quantum networks where delicate links stitch together distant processes. What then is the picture to sleep by? Some see entanglement as the ordinary state of things, with isolation the exception, a universe inherently relational, where parts are defined by the webs they form. Others go further. Perhaps space-time itself is woven from entanglement. Cut enough threads and geometry unravels. Tie threads in a new pattern and a wormhole, and Einstein-Rosen bridge is a metaphor for those correlations. Whether that metaphor is literal or merely luminous, it invites a tender thought. Connection precedes distance. Notice your breath, an in and an out. The room is one thing, your body another, yet sensations cross the boundary without effort. In physics, as in life, relationships carry meaning that objects alone do not. Entanglement doesn't let us send messages faster than light. It doesn't break causality. It simply writes harmony into pairs and trios of systems, so that when one note is struck, the chord is already implied. Let that image settle, 2 photons born together, then separating like siblings who can still finish each other's sentences. Distance changes the root of the sound, not the fact of the song. Imagine a theatre where the set exists as mist until an audience member sits down. In quantum mechanics, the set is the wave function, a soft catalogue of everything a system could be. Left alone, it evolves smoothly, like music without a listener. But the moment we measure, shine light, place a detector, let the system brush against a warm environment, the possibilities pinch into one outcome. A dot appears on a screen. A pointer lands on a number. The mist becomes a chair in row C, seat dosi. Why does this happen? The equations that guide the wave function, Schrödinger's equation, are gentle and reversibly. Measurement, by contrast, is abrupt and seemingly irreversibly collapse. Where does collapse come from? One path says there is no collapse at all, only their coherence. The system entangles with its surroundings, scattering information into air, dust, and heat. Interference between alternatives becomes effectively impossible, and a single story emerges for us because we can't reassemble the lost phases. In this view, measurement is just ordinary physics scaled up. The set hardens because too many hands have touched it. Another path keeps collapse, but makes it a physical law, spontaneous, rare, and more likely as objects get larger, so tiny things retain their quantum shimmer longer, while tables and moons snap to a single state almost immediately. A third path, many worlds, lets every outcome happen, each in its own non-communicating branch. Nothing pinches, the audience multiplies. You, here, see one dot. Another, you, there, sees another. Each story soothes one itch and leaves another. Decoherence explains why interference vanishes, but not why any single outcome feels selected. Spontaneous collapse theories add a mechanism, but must fit tight experimental bounds. Many worlds preserves mathematics, but stretches intuition. If branches are real, what counts as probability? Meanwhile, working physicists build devices that lean on the mystery quantum computers that protect fragile superpositions, measurement schemes that weakly peak without fully collapsing, protocols that harvest information from entanglement like careful gardeners. The problem remains not of calculation, but of meaning. Breathe in. Notice how the question itself slows the mind. Breathe out. Let the urge for a final verdict ease. Perhaps observer is not a person but any irreversibly imprint. Perhaps reality is a book that writes itself the moment ink touches paper. Perhaps the book was always a library. For tonight, it's enough to feel the hinge. Before touch, many. After touch, one. The click of that hinge is the softest kind of thunder. Place a paperclip on your desk. Now lift it with a small magnet. In that easy gesture, electromagnetism overwhelms the pull of an entire planet. Gravity, the architect of galaxies, is at particle scales astonishingly feeble. Physicists speak of the hierarchy problem. Why is gravity's characteristic scale so distant from the others? Why do the strengths of nature's forces live on such different rungs of the ladder? One family of ideas invites hidden rooms, extra dimensions curled too tightly to see. If gravity can leak into those dimensions, while electromagnetism and nuclear forces are confined to our familiar three, then gravity would appear diluted here, weak, not by nature, but by spread. Another family imagines screening or running. The strength we measure is not the true depth of gravity's well, only its surface behavior after quantum effects reshuffle contributions. There are proposals where the graviton, the hypothetical carrier of gravity, is massless but unusually shy. Others where it carries a whisper of mass, changing gravity's reach across cosmic scales. Modified gravity theories try to explain galaxy behavior without invoking dark matter, adjusting the law itself in low acceleration regimes, though each adjustment must survive a gauntlet of solar system and cosmological tests. At the smallest distances we can probe, gravity is smooth and classical, refusing to reveal the quantum grain we expect. At the largest scales, its guidance is plain: orbits, lenses, waves from colliding black holes. LIGO has heard space-time sing. Between those extremes lies the riddle of strength. Why should the universe be built so that gravity becomes king only when masses are vast and distances wide? Perhaps because a cosmos with stronger gravity would collapse too quickly for long stories. Perhaps because stars need a delicate hand to live long enough to forge carbon and iron. Perhaps because the weakness we see is the echo of deeper architecture, not a flaw, but a feature. Let the puzzle feel friendly. Gravity's gentleness is the reason mountains do not crush us and planets can cradle patient oceans. Its persistence across emptiness is why galaxies spiral without strings. Inhale, feel the slight weight of your body meet the bed. Exhale and imagine that weight as a conversation with the earth, quiet and continuous, older than language. Somewhere, the explanation waits behind a door shared with our next mystery. We keep two exquisite clocks, general relativity times the grand ballot, planets, stars, expanding space, black holes curving the stage itself. Quantum mechanics keeps the whispering metronome for atoms and fields, where randomness and interference shape every note. Each clock is precise, each rules its own hall, but set them on the same table in the heart of a black hole at the first instant of the Big Bang, and their ticks do not agree. Infinities spill like beads from a cut string. The great synthesis, the quantum theory of gravity, remains unfinished. There are trails through the forest. String theory replaces particles with tiny vibrating loops. Different notes become different particles, gravity included. The mathematics is lush, unifying forces in higher dimensions, hinting at deep dualities, where a gravity-filled world mirrors a gravity-free quantum theory on its boundary, a whisper known as holography. Yet concrete, testable predictions at accessibly energies are scarce. Loop quantum gravity takes another route, quantizing space itself into finite chunks of area and volume. Geometry comes in pixels, and Big Bang singularities soften into bounces. It yields clean, background-independent math, but struggles to include the full particle SU and match the precision of quantum field theories we already trust. Other approaches, causal sets, asymptotic safety, emergent spacetime from entanglement or computation, offer compelling sketches, each capturing a facet, none yet the full portrait. Experiments listen at the door. We hunt for imprints of Planck-scale discreteness in high-energy gamma rays, for deviations in gravitational waves, for delicate anomalies in tabletop interferometers, for cosmological fingerprints in the oldest light. So far, the universe answers with a serene face. Relativity holds on the large, quantum theory on the small. The seam where they stitch remains under the hem. It's tempting to treat this as an absence, but it can be a lullaby. Two masterworks playing side by side, each flawless in its register, awaiting a conductor who can blend them without drowning either melody. Breathe in, let curvature and quanta share a room in your mind. Breathe out, feel how natural it is that profound truths arrive in chapters. Somewhere ahead, perhaps in a whisper from a black hole horizon, perhaps in a ripple from the early universe, the downbeat will fall and the clocks will lock in time. Until then, we listen, patient, as the night turns softly from mystery to mystery. Picture a night so deep that light itself forgets the way home. That is the inside of a black hole as our equations describe it, a region wrapped by an event horizon, a one-way boundary where escape is no longer part of the grammar. Cross it, and every possible path your future can take curves inward, like raindrops drawn to a drain, like thoughts sliding towards sleep. From outside, we watch matter spiral down, heat into a bright final flare, and then fall silent. Time for the infaller behaves strangely. In their own experience, they drift past the horizon without fanfare. From our far vantage, their last moments seem to freeze and fade, red shifted into darkness. Two truths, both real in their frames, braid a single story that denies us a shared view. Deeper in, general relativity predicts the crushing pull grows without limit. Space-time narrows. Directions simplify. Inward becomes the only destiny. If we trust the classical math, all roads end at a singularity, a point of infinite density where curvature spikes and known law dissolves. But infinity is often a signpost that reads the map is incomplete. Quantum physics, which keeps restless counsel at small scales, refuses to be left at the door. Perhaps the interior contains a finite core. Perhaps the very notion of place unravels. Perhaps the geometry undergoes a quiet phase change into something that is not quite space and not quite time. We can't send cameras in. No signal escapes to carry the tale. Instead, we learn by peripheral senses, the way black holes ring like struck bells after mergers, gravitational waves fading in pure tones, the crisp, circular shadow seen by horizon-scale telescopes, the feeding habits traced in X-rays, the choreography of stars whipped around an invisible partner. These outskirts sing of the inside without revealing its score. Theories multiply, firewalls that flare at the horizon, smooth crossings that honor the equivalence principle, quantum hair, subtle imprints that store information. Each picture protects one cherished law and imperils another. Let the door stay closed for tonight. A black hole's interior is a dream the universe keeps to itself. You can lie back and feel its gravity as an idea, a hush so complete it becomes a cradle for paradox. Somewhere beyond eyesight, space-time is doing something we don't yet have words for. Breathe in and out, and let not knowing be as soft as velvet. In many equations, when conditions are pushed to extremes, numbers run away. The curve sharpens to a cliff. The denominator becomes zero. The result shouts infinity. In relativity, follow gravity inward beneath a collapsing star, and the math points to a singularity. Density and curvature diverge. Clocks lose meaning, and geodesics, the straightest possible paths, end abruptly. In cosmology, wind the clock backward to the Big Bang, and you meet a similar wall. Singularities are places where the story stops mid-sentence, but physics prefers sentences that end cleanly. An infinity is often a flare telling us our language broke. When we learned quantum electrodynamics, we tamed certain infinities by renormalization, repackaging what charge and mass mean so predictions came out finite and accurate. With gravity, the same trick slips away. Space-time's dynamism ties geometry to energy in loops that fight neat bookkeeping. Many suspect the cure is to quantize space-time itself. In loop quantum pictures, areas and volumes come in discrete quanta. The Big Bang's singularity softens into a bounce, a high-density bridge from a prior branch. In string theory, singular points can be replaced by smooth, higher-dimensional throats. New species of extended objects spread what a point would have concentrated. There is also the cosmic censorship hope that naked singularities exposed infinities without horizons do not occur in nature, that horizons always cloak the breakdown, so external predictions remain sensible. Numerical experiments in curved space tease the boundaries. Some setups hint at exposure, others restore modesty with a horizon's quick veil. Meanwhile, the Penrose-Hawking theorems prove that under broad conditions, geodesic incompleteness, our operational definition of singularity, really does arise if gravity keeps faith with energy conditions. The question then is not whether our math hits a wall, but what replaces the wall when a better theory arrives. You can think of singularities as the universe clearing its throat, warning that the current song cannot hit that note. It is not failure, it is opportunity signposts toward the next language, where space and time are not the final nouns, but woven from something smaller, stranger, kinder to extremes. For now, let the cliff be beautiful. Edges make landscapes. Breathe in, feel how even a pause has shape. Breathe out, and leave a margin for the theory yet to be written. Imagine tossing a book into a campfire. The pages curl. The ink smears into smoke and ash. If you knew the positions and motions of every molecule, classical physics promises that the text is not truly lost, it's dispersed. In quantum mechanics, this promise is sacred. Unitarity says information flows forward in time without destruction, scrambled, but in principle recoverably. Now replace the fire with a black hole. Matter falls in. From far away, the only story left to tell is mass, charge, and spin. Everything else, titles, photographs, the quiet specifics of a summer afternoon, seems erased behind the horizon. Then comes Hawking's profound whisper. Quantum effects near the horizon make black holes radiate, slowly evaporating over stupendous times. But Hawking radiation looks thermal, random, indifferent to what fell in. If the whole vanishes into featureless heat, where did the information go? If it's destroyed, quantum theory bends. If it escapes, how does it ride out on radiation that seems to carry no imprint? If it remains inside, dot into the centperi, dot into the 5. What holds it when the container is gone? Thus the paradox, gravity's sternness versus quantum theory's memory. The possible doors each open onto further rooms. One says, the radiation is not perfectly thermal. Subtle correlations too fine for early calculations encode the story. Over an evaporation timeline, these correlations could swell after the page time, letting information leak out in a long, delicate exhale. Another says the information is stored on the horizon itself, holography, with the surface's area measuring not ignorance but inventory. The ADS CFT correspondence gives this hope teeth in special spacetimes. A gravity world equals a quantum theory without gravity on its boundary, and in that dual picture, unitarity is manifest. A third path conjures firewalls. Perhaps quantum entanglement that would make the horizon smooth breaks down. The infaller meets a searing wall of quanta, so that outside observers can keep unitarity clean. But firewalls offend relativity's local calm, which promises a gentle crossing for large holes. Other proposals speak of quantum hair, soft charges, wormhole-like connections that let interior and radiation share a ledger without faster-than-light cheats. No single answer has tucked every sheet into order, but progress feels like dawn light. Replica wormholes and island formulas have recently reproduced the expected page curve in toy models, suggesting that when gravity and quantum information are married carefully, black holes do keep their letters. The full novel remains to be assembled. For tonight, let the paradox be a bedtime story about memory, that the universe may be a meticulous librarian, misplacing nothing, even when shelves look like shadows. Inhale, exhale, and imagine the faintest script written on the edge of night, legible only to the future. Imagine a horizon not as a line on a map, but as a place where ideas change temperature. In the mid-1972, Stephen Hawking found that if you lace quantum fields through the curved fabric around a black hole, a faint heat leaks out Hawking radiation. Not flames, not sparks, but a whisper of particles born from fluctuations at the edge. Pair production near the horizon lets one partner fall while the other escapes, and to distant eyes the whole glows imperceptibly for large holes, brighter as they shrink. The logic binds gravity, quantum mechanics, and thermodynamics into one astonishing braid. Black holes have temperature and entropy. Horizons carry information the way a surface carries frost. So why haven't we seen it? Nature hides the signal beneath louder songs. Real black holes feast in messy neighborhoods, hot gas, magnetic storms, violent disks emitting X-rays and jets that drown the faint thermal glow predicted by Hawking. For a black hole the mass of the Sun, the Hawking temperature would be colder than the cosmic microwave background. The universe's afterglow outshines it. Only tiny black holes' primordial embers, never yet confirmed, would radiate strongly enough to be obvious, winking out like cosmic fireflies. None have been caught. Still, we listen indirectly. Tabletop analogues borrow the mathematics of horizons, flowing fluids, Bose-Einstein condensates, optical fibers, tuned so that waves meet a point of no return. In these laboratories, horizon-like boundaries emit phonons or photons with thermal spectra, Hawking's logic replicated in safer domains. These are metaphors with math behind them, not proofs about astrophysical holes, yet they steady our confidence. Horizon mass quantum field radiation with a temperature. Observationally, we watch black holes ring after mergers and cast sharp shadows in radio wavelengths tests of gravity's stagecraft that, so far, keep the theory's spine straight, though they do not touch the faint thermal edge. Whether Hawking radiation is precisely as first derived or subtly dressed by quantum gravity corrections remains part of the larger riddle of information. If it is real, black holes are mortal, their endings measured in unimaginable ages. If it is not, then something even stranger guards unitarity. For tonight, let the question cool on the windowsill of your mind. Picture horizon under starlight, radiating slower than seasons, slower than civilizations, slower than memory patience made into physics. Breathe in and out and feel how some truths require not louder instruments, but longer listening. Hold 2 sheets of paper up to a lamp. Now, imagine pressing your thumb through both at once, making a tunnel where none belonged. In Einstein's equations, certain solutions resemble such tunnels, wormholes, bridges, connecting distant regions of space-time, perhaps even separate universes. The math is permissive, reality is stricter. Traversable wormholes appear to require forms of exotic matter with negative energy density to prop their throats. Open material, no known recipe supplies in bulk. Ordinary gravity pinches them shut the way a heavy door closes itself. Black holes, meanwhile, are nature's sturdy doors, one way, locking behind you at the horizon, yet the hints keep glimmering. Theoretical work links entanglement and geometry with a provocative slogan, ER igual à EPR, the idea that an Einstein-Rosen bridge, a non-traversable wormhole, might be the geometric avatar of entangled pairs. 2 systems deeply correlated could be thought of as connected by a throat that no traveler can cross, while information carefully encoded in correlations still finds lawful ways to match up across the divide. In certain toy models and holographic dualities, adding just the right shock of interaction can render a wormhole briefly traversable, letting a quantum message slip through without violating causality. These are controlled fictions with rigorous math lanterns, in a maze suggesting that space-time and information are not strangers. Another speculation walks through the black hole's heart. If the classical singularity softens in quantum gravity, the interior might bounce, budding a new expanding region on the far side, a baby universe. From the outside, nothing escapes. From the inside, a new sky is born. The parent cosmos pays a small price in mass. The child inherits a whole horizon's worth of possibility. Testable? Not directly. The horizon is loyal to secrecy. But such ideas shape how we think about beginnings and endings, about conservation and novelty. Let the romance and restraint sit together. Physics encourages poetry, then asks it to pass exams. For now, wormholes remain diagrams, not highways. Baby universes remain lujabes, not itineraries. What does remain, solid as a handrail, is the intuition that connection, mathematical, informational, perhaps geometric, is deeper than separation. As you breathe, picture dark doors speckled with starlight, not threatening, only quiet. Some open, some do not, some are mirrors, some are painted on. We knock with equations. The night answers in its time. Return to the universe's long night, the cosmic dark ages, after the first light faded and before the first stars were born. There were no metals then, only hydrogen, helium, and traces of lithium. Gravity gathered gas into halos. Density grew. The first sparks were poised. But metal-free gas cools poorly, without efficient radiators. Clouds resist collapse. Somehow, the young cosmos solved this, giving rise to population to 3 stars, titans hundreds of times the sun's mass, blazing blue-white, living fast and dying loud. We have never seen one directly. Their lives were brief, their era remote. Yet, the chemical fingerprints left on later generations, peculiar ratios in ancient stars, whisper of their existence. What, precisely, lit them? Perhaps molecular hydrogen, rare but present, allowed the first clouds to shed heat just enough to condense it. Perhaps cold streams fed halos steadily, bypassing the angular momentum roadblocks that stall collapse. Simulations thread these ingredients into tapestries of possibility. Filaments feeding knots, protostellar disks growing, fragmenting, merging, feedback from the first light, both helping and hindering subsequent births. A massive star's ultraviolet glare can strip electrons and alter chemistry. A supernova's shock can compress neighboring clouds, kindling or quenching by turns. The balance is delicate. Push too hard and you blow the cradle apart. Push too softly and the infant never cries. Why does it matter? Those first giants forged the universe's inaugural metals: carbon, oxygen, iron seeding space with the elements that later built planets, oceans, chlorophyll, bone. Their deaths, hypernovae, and pair instability supernovae, may have carved early bubbles in the intergalactic medium, shaping where the next galaxies could grow. They likely birthed the initial black holes that, against our expectations, swelled quickly into the supermassive anchors we already see less than 1 billion years after the Big Bang. We search with new eyes. Infrared observatories sniff the red-shifted glow of the earliest galaxies. Spectra of ancient halo stars in our own Milky Way carry ancestral recipes in their atmospheres. 21 centimeter cosmology hopes to map the faint, collective murmur of neutral hydrogen as the first light reionized the fog. Each method is a hand outstretched to a past without witnesses. For sleep, keep the image simple: a wide, dark seer, and then far out, one bright boat lamp, then another. No less miraculous for being natural, the first stars turned a silent universe into a singing one. Breathe in little sparks on black water. Breathe out the knowledge that all the iron in your blood began as a shout from those brief suns. Imagine opening a photo album of the cosmos and flipping back to the very first pages, faint, red-shifted scenes, less than 1 billion years after the Big Bang. Already there, like dark crowns on infant galaxies, sit supermassive black holes with masses of hundreds of millions or even billions of suns. By our usual growth recipes, stars collapsing into modest black holes, mergers stacking them, slow meals of gas spiraling inward, there simply isn't enough time. The early universe is a hurried place. Yet, these giants look too hurried, arriving before the bakery lights have fully warmed. One proposed shortcut is direct collapse. Instead of building from small seeds, a pristine metal pour, gas cloud might skip star formation altogether and plunge inward under its own gravity, forming a black hole of 10,000, 100,000, even 1 million solar masses in one go. But for gas to fall without fragmenting into stars, cooling must be suppressed, perhaps by strong ultraviolet light, from a neighboring proto-galaxy, perhaps by the dynamics of rapid inflow along cosmic filaments. Another route starts with population 3 titans. If the first stars were truly enormous, their deaths could leave black hole seeds far larger than those born today, jump-starting growth. Add to this the possibility of super Eddington accretion brief feasts where gas piles in faster than the textbook limit allows, funneled by thick, clumpy disks that trap their own light, and the timeline begins to stretch just enough to fit. There are also the quiet conspiracies of mergers. Small galaxies collided often in that youthful era, their central black holes sinking together through stellar crowds and gaseous fog, feeding as they waltzed. Each collision both fattens the whole and stirs new fuel inward. Simulations paint turbulent, luminous episodes, cold streams funneling matter, like rivers into a whirlpool, feedback winds that both quench and cool the next gulp, a rhythm of burst and rest, burst and rest. We look for signatures. Do the earliest quasars sit in special neighborhoods, intersections of filaments where fuel is abundant? Do we see the chemical innocence expected of direct collapse cradles? Can future gravitational wave ears hear the heavy footfall of early black hole marriages? The answers are not asleep, they're simply far. For now, close the album and rest with the feeling of a mystery that is not menacing, only grand. Somewhere between the first stars and the first cities of galaxies, nature found a fast lane. Breathe in. Imagine a dim universe punctuated by sudden beacons. Breathe out. Let the thought become a low, friendly hum in the dark. If you could rise above the Milky Way and look down, you'd see arms sweeping out in cool blue arcs, lanes of gas, and young stars curling like slow smoke. Spiral galaxies are common, almost archetypal, yet the precise origin and persistence of their arms remain unfinished music. Are the arms made of the same stars, circling like rigid blades? Or are they patterns traffic waves on a stellar highway through which stars and gas flow, bunching and thinning as they pass? The classic picture speaks of density waves, long-lived patterns rotating at their own pace, shepherding gas into compressions that spark star birth. Newborn clusters light the arms, older stars drift on, leaving the pattern behind. It's a lovely idea, structure without solidity, like a standing wave on a violin string, but galaxies are messy. Bars twist in many disks, steering orbits, interactions with neighbor galaxies tug and torque, seeding fresh asymmetries. Clumps of star formation push back with winds and supernovae, churning the disk. In simulations, spirals can arise from swing amplification, small disturbances growing as they shear under differential rotation arms that appear, fade, and reform in a restless cycle. Are the arms quasi-permanent or transient but recurrent? The sky offers both personalities, and our Milky Way's self-portrait is hard to paint from the inside. Gas physics complicates the dance. As clouds crowd into an arm, they collapse into stars, then young suns blast feedback into the medium, both feeding and fraying the very structure that birthed them. Dark matter halos cradle the disk, setting the tempo of rotation and the stability of the sheet. Tiny ripples in that invisible scaffold can seed or sustain patterns. Even the thickness of the disk matters. Thin disks favor grand designs. Thicker, hotter disks prefer flocculent, patchy swirls. We read the patterns like tree rings, the spacing of star-forming knots, the age gradients across arms, the pitch angle that measures how tightly they wind, all our soft clues. There may be no single recipe, only families of spirals, bar-driven, tidal-triggered, swing-amplified, density wave-sustained. The common result is an image of calm, carved by ceaseless motion, order coaxed from chaos by rotation's patient hand. For sleep, hold this. A galaxy is a slow whirlpool that teaches water to look like lace. Not fixed blades, but invitations, regions where stars briefly keep each other company before drifting on. Inhale, the curve of an arm. Exhale, the long grace of turning. Every so often, a radio telescope catches a shout-fast radio bursts, millisecond flashes, arriving from far beyond our galaxy. Bright enough that for a heartbeat, they outshine entire galaxies at radio wavelengths. They are brief, sharp, and so far diverse. Some repeat irregularly or in patterns. Others speak once and fall forever silent. Their signals arrive stretched and delayed by the thin mist between galaxies, letting us weigh the cosmos along their path. But their engines remain hidden. One compelling suspect is the magnetar, a neutron star with a magnetic field so fierce it can twist space like wet cloth. Stresses in a magnetar's crust may crack starquakes, snapping magnetic lines and launching radio-bright flares. We've seen at least one FRB coincident with a known galactic magnetar's tantrum, a strong hint that some bursts are stellar lightning from these extreme remnants. But magnetars may not explain all. The most distant, most energetic FRBs might demand cataclysms, compact object mergers, collapses of massive stars, or interactions in the fierce near space of a black hole. Others propose more exotic repeaters, young magnetars, wrapped in denser nebulae, where outflows convert magnetic rage into radio whistles again and again. Locale environments matter. Some FRBs cut through plasma, so tangled their polarization spins like a compass near a storm. Others travel more clear air. A few live in tiny, star-forming dwarf galaxies, some in mature spirals, one in a globular cluster, like setting that challenges the magnetar nursery story. We are likely hearing multiple instruments in an orchestra we've only just discovered. Catalogues grow, interferometers pinpoint bursts to their home galaxies within a hair's breadth. Wide-field surveys catch them in the act rather than in afterglow. Each new localization is a breadcrumb across intergalactic dark. Beyond origins, FARBs are turning into tools. Because their pulses are smeared by free electrons along the way, they can map the missing, ordinary matter thought to drift between galaxies. Their timing can probe plasma in galaxy halos. Their polarization can feel out cosmic magnetism. We are using the unknown to study other unknowns, a lovely symmetry. For now, let the image be this. Somewhere, a city-sized star flexes its iron skeleton, and a radio shout sprints across billions of light years to tap our instruments like a fingertip on glass. Millisecond, and gone. Breathe in, the suddenness. Breathe out, the long travel that makes such brevity profound. Imagine a lighthouse made of matter, so then say a teaspoon would outweigh mountains. That lighthouse spins sometimes hundreds of times each second, and its beams sweep the cosmos. In radio, X-ray, even gamma light. These are pulsars, neutron stars left behind when massive suns explode. From Earth, each sweep is a tick, and some ticks are so regular they rival, even surpass, the best atomic clocks we can build. The wonder isn't that the clock keeps time, it's how it keeps it so well while living in such violence. A neutron star is a city-sized sphere with a mass greater than the Sun. Its crust may be a lattice of exotic nuclei. Beneath, neutrons press into superfluid states, frictionless, sails that flow without losing energy. Magnetic fields trillions of times Earth's carve funnels at the poles, where charged particles roar outward along field lines, lighting the beams. In that orchestra, one expects a little wobble, yet the rhythm holds. The star's moment of inertia is enormous. Simply rotational inertia lends stability. Superfluid interiors can couple to the crust, like flywheels, sharing angular momentum and damping tiny jitters. The magnetosphere's plasma, co-rotating like a luminous skirt, can self-organize so that emission regions stay in step, beat after beat. And still, there are glitches, sudden, tiny upticks in spin, like a violin string tightening mid-song. These may be starquakes, the rigid crust cracks as the star slowly spins down, letting superfluid vortices unpin and dump their stored angular momentum into the crust in a staccato transfer. After a glitch, the star relaxes, as if exhaling. There are also timing, noise, and mode switches when a pulsar's beam subtly changes shape, shifting arrival times by microseconds. Each deviation is a clue to interior physics we cannot create on Earth's superconducting cores, nuclear pasta phases, pinning forces between vortices and lattice. Why the overall precision? Partly the sheer mass and compactness that anchor rotation, partly the self-regulating plasma lantern, partly deep, frictionless layers that keep time like gears in oil. We harness this steadiness to weigh invisible companions, to map spacetime ripples from giant black hole binaries with pulsar timing arrays, to navigate spacecraft by the sky's most reliable metronomes. Breathe in, an entire star spinning like a perfect top. Breathe out, the tick that crosses light years to land within a microsecond. And already the metronome of the extreme leads us to its wilder cousin, the star, whose magnet sigh can crack space like ice. Take a neutron star and turn its magnetic field up until it becomes unreal magnetars, wear fields 1,000 times stronger than typical neutron stars, 1,000,000,000,000 times stronger than Earth's. With such fields, the vacuum itself behaves differently. Atoms become spindly, squashed by magnetic pressure. Light can split into light. Most nights, a magnetar is only a quiet ember in X-rays. Then, without warning, it flares, releasing in a blink the energy our sun emits in tens of thousands of years. Space heaves. Detectors on satellites blink in alarm. The star goes silent again, as if nothing happened. Why? One story begins in the crust, a kilometer-thick shell of dense, crystalline nuclei. As the interior magnetic field twists and evolves, stresses build. When the crust can no longer bear them, it yields a starcake. Crustal plates slip by millimeters, but in a magnetar's context, that's a tectonic lurch. Magnetic field lines, frozen into the star and its magnetosphere, snap and reconnect, an astrophysical cousin of solar flares, supercharged by orders of magnitude. The reconfiguration dumps energy into the surrounding plasma, launching an expanding, relativistic fireball that shines in hard X-rays and gamma rays. Afterglows flicker as the magnetosphere resettles. Oscillations ring like aftershocks, sometimes traceably in the light curve as quasi-periodic whispers from the star's own seismic modes. Another thread focuses on plastic flow. Rather than a single brittle break, the crust may slowly creep, feeding steady stresses into the magnetosphere until instability tips the system into a flare. The balance among interior evolution, crustal yield strength, and magnetospheric reconnection likely varies from magnetar to magnetar, explaining why some burst in noisy storms while others bide their time between giant flares. Recently, a fast radio burst, aligned with a galactic magnetar outburst, a strong hint that at least some FRBs are radio aftershocks of magnetic tantrums, coherent radio waves born from shocks or master processes in the blast's wake. And yet, puzzles persist. Why do some magnetars live in quiet shells, while others sit in wild, high magnetization neighborhoods? Why do radioloud magnetars sometimes switch on like beacons, then fade to silence, as if an unseen dial changed the magnetosphere's mood? The field's geometry twists, toroids, open lines matters. So does the star's age, cooling rate, and superfluid interior. We are reading weather reports from a place where magnetic field is almost a material. Inhale, a storm that begins inside iron and ends as light. Exhale, and follow one more bolt that travels farther than any flare-charged particles sprinting across the void. Every second, the Earth is peppered by cosmic rays charged particles, mostly protons, sometimes heavier nuclei, accelerated to astonishing energies. The garden variety ones likely come from supernova shockwaves, blast fronts ploughing into interstellar gas, turning turbulence into a particle slingshot. But at the very top of the spectrum, a rare few arrive with energies so absurd that each particle carries the wallop of a fast-pitched baseball. They are solitary lightning bolts in a rain of sparks, and their origins remain unsettled. Magnetic fields thread space like invisible spaghetti, and charged particles wiggle along them, their paths bent and scrambled. By the time an ultra-high energy cosmic ray hits our atmosphere, its trajectory is a forgetful line, pointing only vaguely back to its birthplace. We detect the air showers. These bullets create cascades of secondary particles spreading across kilometers of ground and reconstruct their energies and arrival directions. Patterns hint at sources near the cosmic neighborhood within roughly 100 megaparsecs, because interactions with the cosmic microwave background drain energy from the highest flyers. The GZK limit turns distant runners into joggers. What engines can push particles so far up the scale? Candidates abound. Shock fronts in jets, launched by active galactic nuclei, where supermassive black holes fling matter near light speed, giant lobes of radio galaxies acting like vast inductors. Gamma-ray bursts, brief but ferocious, whose internal and external shocks might double as accelerators. Newborn magnetars with millisecond spins and screaming fields whose winds could fling heavy nuclei outward. Even the shocks along large-scale structure where intergalactic gas streams collide may contribute a background. Composition matters. If the primaries are protons, certain source classes fit. If they're heavier nuclei, different astrophysical conditions are forebode. Observatories report mixed hints, like a chord with uncertain base. We improve our maps with multi-messenger ears neutrinos that ignore magnetic meanders. Gamma rays that point straighter, hoping correlations will name the culprits. Early alignments tease, but don't clinch. The sky may be telling multiple stories at once, with different populations at different energies. Meanwhile, the most extreme events arrive like rare, bright fish, memorably, statistically stingy. They keep us patient. For sleep, keep one image. A single proton traveling for tens of millions of years, nudged by fields, harried by background light, finally striking the air above you and turning into a blossom of particles that patter invisibly across the night. Inhale, the long journey of one tiny traveler. Exhale, the sense that somewhere the universe runs accelerators grander than any ring we could ever build. Close your eyes and picture the universe, not as a scatter of points but as lace-bright filaments and clusters, where galaxies crowd together, separated by rooms of near-nothing called voids. Some are hundreds of millions of light-years across, volumes so empty that you could travel for ages and meet only a handful of lonely galaxies. How did these hollows become so grand? The standard tale says tiny ripples in the infant universe grew under gravity. Overdense regions condensed into the web's bright threads, while underdense regions drained, their matter migrating outward like dew sliding into grooves. Voids, then, are the negative of structure, swelling as the rich grow richer and the poor grow emptier. Simulations support this broad rhythm. Start with the faint mottling we read in the cosmic microwave background. Let gravity work for billions of years, and filaments and voids blossom naturally. But the details carry a soft disquiet. The largest observed voids sometimes seem too big, their statistics nibbling at the edges of expectation. Are we seeing extremes that just happen in a vast sample, or hints that something about cosmic expansion or gravity's law bends a little in the dark? Voids are exquisitely sensitive to what pushes space apart dark energy and to how gravity tugs on very large scales. Their sizes, shapes, and the way they stack and merge over time become probes of the deepest rules. Voids also warp light, but in reverse. where clusters magnify, voids slightly the magnify, thinning the background glow. They chill the cosmic microwave background by a whisper as photons cross their expanding hearts. Galaxies at their edges are stretched, their motions tracing the breath of emptiness. In these subtle signatures, cosmologists read the pressure of the vacuum and the handwriting of gravity. Some even wonder whether our patch of space sits near a supervoid large enough to nudge certain cosmic coincidences, an idea tempting and contested. There is a gentler lesson too. Emptiness is not nothing, it is a character in the story. In human terms, we think of absence as lack, but in cosmic terms, absence shapes the stage. Voids guide filaments, set tempers, and give contrast to the bright. Breathe in. Imagine crossing a room so wide you forget what room means. Breathe out. Feel how stillness has architecture. On the far side of that stillness waits a question about endings. If the universe has grown hollows this large, how will the tale itself conclude? Stand at a shoreline at dusk and listen for the future. The sea keeps moving, so does space. Galaxies drift apart on the swell of expansion, and the long-term weather of the cosmos depends on what fills it. If dark energy is a constant, the distance between island galaxies will widen forever. Star formation will fade. As fuel is spent, stars will redden, die, white dwarfs will cool, black holes will swallow and slowly evaporate. Protons may decay if certain theories are right. This is heat death, not heat everywhere, but uniformity so complete that no more work can be done. A hush where energy differences to exploit have thinned to almost none. It is a very long lullaby, trillions upon trillions of years, ending not in drama, but in dimness. Another page imagines gravity reclaiming the stage. If dark energy is not constant, if it weakens or reverses, expansion could slow, stop, and reverse. Galaxies would approach, background light would blue, temperatures would rise, structures would collapse into a final conflagration, the big crunch. Some versions let a bounce follow a new expansion, beyond the ashes, turning the end into a gate. In a different mood entirely, if dark energy grows stronger with time, its repulsive pressure could tear everything. First galaxy clusters unbind, then galaxies, then solar systems, then planets, then molecules, eventually the big rip, where even atoms lose their hold, space stretching faster than forces can keep pace. Between these archetypes lives a garden of subtler fates. Perhaps dark energy drifts towards zero, leaving a cold but gently coasting universe. Perhaps new physics turns on in the far future. Phase changes in fields we barely know, black holes linking to baby universes and bleeding the darkness into new light elsewhere. Perhaps the final state is not silent at all, but a slow computation where rare fluctuations ignite brief islands of order in an endless sea. Boltzmann whispers that unsettle and intrigue. For tonight, what matters is the texture of the unknown, not the vote count among models. The sky over your window will not change its mind in your lifetime. The nearest star will still rise and set as you sleep. Long fates belong to long breaths. Inhale, feel the present gather like warm fabric. Exhale, let far futures become soft background, not burden. And before we go too far forward, let's glance backward to the earliest fraction of a second, where the whole plot may have been set by a single, explosive hush. Rewind the universe to its first whisper, and you meet a puzzle. Why is the cosmos so smooth on vast scales, and yet seeded with just enough wrinkles for galaxies to grow? The most elegant reply is inflation, a brief, blistering episode when space itself expanded faster than any signal could cross, ironing out curvature and mixing, while quantum jitters stretched into the faint fingerprints we see in ancient light. Inflation is a story that explains much, but what started it, and just as crucial, what stopped it at the right moment. In many models, a field call it the inflaton, perched on a high plateau of potential energy, driving expansion like a cosmological pedal pressed to the floor. While the field lingered, space ballooned. When it rolled down or tunneled off the plateau, inflation ended, converting stored energy into a hot fog of particles in a process called reheating. The spectrum of primordial ripples we observe favors a field that strolled more than sprinted, and it disfavors overly large gravitational wave backgrounds, clues that prune families of models. Yet, the inflaton remains a role without a confirmed actor. Is it a new field unto itself? A borrowed face of something from high-energy physics? A mirage of a deeper, emergent mechanism? Precision lingers at the exit door. If inflation lasted a smidge too long, today's universe would be emptier and colder than it is. Too short, and it wouldn't look nearly as flat and even. If reheating were too violent or too meek, it would spoil the delicately scale-free pattern of fluctuations we read across the sky. How did the field know to stop just so? In eternal inflation pictures, most regions keep inflating while rare patches like ours drop out, a multiverse of bubbles. Beautiful, if true. Difficult, if you crave tests. Meanwhile, alternatives ekpyrotic and bouncing cosmologies offer different beginnings. Slow contraction, then rebound, smoothing without a superluminal sprint. Each faces its own gauntlet of consistency and evidence. Observations are our lullaby and metronome. We scrutinize the polarization of the cosmic microwave background for the faint spiral signature of primordial gravitational waves. We survey large-scale structure for non-Gaussian quirks, small departures from perfect randomness that different models predict. The sky answers in measured tones, tightening bounds, inviting patience. Let the picture simplify for sleep. Imagine a sheet rumpled on a bed. A hand passes once, smoothing most of the creases, but leaving fine texture, the very texture later woven into stars and you. What was the hand? Why did it pause where it did? These are questions that do not demand an instant reply. Breathe in the evenness of the night around you. Breathe out the faint, necessary ripples that make the night interesting. Ahead, our story tilts from the birth of the cosmos toward the birth of life, carrying the same hush of wonder in a smaller key. Set the scene. A young Earth under a copper sky, continents still assembling, oceans steaming with minerals, lightning stitching brief veins of fire through thick air. In this laboratory without walls, simpler molecules wandered and met water, carbon dioxide, nitrogen, traces of sulfur and phosphorus, wandering into pools, vents, shorelines, and storms. Experiments in our time can coax amino acids, lipids, and nucleobase precursors from such conditions. Yet, the key turn the step from chemistry to biology remains a soft, private moment the planet never wrote down. One story begins with RNA, a molecule that can both store information and catalyze reactions. Perhaps short RNA strands formed on mineral surfaces clung to clays or basalts and learned to copy parts of themselves with help from metal ions. A world of ribozymes, tiny molecular helpers, might have bloomed first, only later handing the archivist's job to DNA and the builder's job to proteins. Another story seeks life's match in metabolism-first models, networks of reactions around metal-rich rocks and gradients that cycle energy, with genetics emerging as bookkeeping after the market was already alive with trade. A third view keeps the door open to delivery from space meteorites and comets rich in organics, splashing ingredients into terrestrial soups, not as magic, but as extra inventory for a hungry planet. But how did order persist in a world so noisy? UV light shredding bonds, waves diluting mixtures, heat undoing progress. Cycles may be the answer. Wet-dry rhythms to condense and link, hot-cold rhythms to separate and sort, light-dark rhythms to drive redox chemistry. Think of the planet as a patient drummer, beating patterns into chemistry until a self-sustaining loop caught and would not let go. Somewhere, a small network learned to harvest energy, to make more of itself, to compete and evolve. From there, novelty was inevitably better catalysts, sturdier compartments, more faithful copying, a language of triplet codes. We do not need tonight to crown a single hypothesis. It is enough to notice how many doors the Earth held open at once, vents that whisper heat, pools that remember yesterday's dryness, minerals that organize, skies that spark. Breathe in, the slow patience of cycles. Breathe out, the idea that life was not a lightning strike but a dawning degrees of almost gradually tipping into yes. The first spark may never be filmed, but its warmth is everywhere now, including in you. Picture two cradles. In the first, hydrothermal vents on the ocean floor, chimneys of iron and sulfur breathing hot, alkaline fluids into cold seawater. Tiny mineral pores act as natural compartments, gradients of pH and voltage drive reactions, and metal catalysts offer patient hands. Here, molecules do not float lost. They are herded through labyrinths, encouraged to exchange energy and parts. A metabolism-first story feels at home. Cycles like the citric acid pathway, sketched in outline before Jennings arrived to write the score. In the second cradle, shallow pools on volcanic ground, fed by rain and geysers, warmed by sun and cooled by night. They fill and dry, condensing monomers into longer chains, then refill to test which chains can survive, fold, and pair. UV light, harsh but generous with energy, can both break and make. Minerals on the pool's edge can template and sort. Lipids can gather into bubbles and then fuse, trying on the idea of a membrane. In this cradle, strands of RNA or proto-RNA find chances to grow, copy, and mutate, inventing small catalysts that favor their own persistence. Which cradle was first? The fossil record is a shy witness. The earliest cells we can infer already knew many tricks. The truth may be plural. Perhaps vent-borne metabolisms met pool-borne genetics. Perhaps pools incubated codes while vents taught energy discipline. Perhaps environments alternated tide pools, communicating with seepage from mineral springs, trading parts like neighbors. The planet did not offer a single lab bench. It offered archipelagos of opportunity. We can feel both places tonight. The vent is a warm hand in cold water, a steady sigh of chemistry sheltered from storms. The pool is a sunlit breath, a rhythm of scarcity and abundance that edits complexity into shape. Breathe in, the hush of the deep, full of gradients. Breathe out, the dry crackle of a shore at noon. Whether life stood up in darkness or in daylight, it learned to keep time with cycles and to turn gradients into memory. The argument between sea and land can soften at bedtime. Two lullabies, one planet, one awakening, sung in different keys. Life is not only reactions, it is organization. A cell is a room with rules. A membrane keeps some things in, some things out. Genes move charges and bits. Information flows from template to product and back again. But before all that choreography, there were simpler actors. Fatty acids, easy to make in early Earth chemistries, and found even in meteorites, spontaneously form vesicles in water, hollow spheres with thin walls. These protomembranes can trap molecules, grow by absorbing more fatty acids, and even divide when shaken by flows, a hint that compartmentalization comes naturally once lipids are present. Inside such bubbles, chemistry can be concentrated. If short RNA strands had already begun to copy, a vesicle that happened to enclose better replicators would fill with them and grow faster, as these strands evolved enzymes that helped harvest energy or synthesize lipids. This is selection at the level of compartments. Bubbles with helpful insides thrive. Bubbles without them fade. Minerals, clays, iron sulfiders might have lodged in walls or interiors, offering scaffolds and catalysts. Membrane compositions could have shifted from leaky fatty acids to sturdier phospholipids as metabolism improved, trading permeability for stability and inventing channels to compensate. Energy is the heartbeat. Primitive cells may have piggybacked on natural gradients in their environment. Alkaline vents, again, offer pH steps ripe for exploitation, gradually internalizing those gradients with primitive pumps and proton circuits. The genetic code, perhaps initially sloppy, tightened as ribosomes sethered some tasks to proteins whose folds offer endlessly varied tools. Somewhere along this path, copying became faithful enough that lineages could persist without losing themselves to error. Error rates fell, sheen lengths grew, cooperation between molecules sharpened into systems. What remains unclear is not whether each piece is plausible. Experiments model many pieces, but how they knit in the right order and timing. Did membranis come first, then genis, or genis first inside mineral pores, then membranis as portable homes? Did metabolism scaffold both from the start, or arrive as a late stabilizer? We may never reconstruct the exact choreography. Multiple dances could have led to similar finales. Let the mystery be kind. You are the descendant of bubbles that learned to keep books, repair walls, and sing electricity across their skins. Inhale. Imagine a tiny sphere closing around a scrap of sunrise chemistry. Exhale. Feel gratitude for compartments, the rooms that let life accumulate, meaning, one reaction, one message, one quiet division at a time. Imagine a long, quiet lather resting in moonlight, 2 rails, 4 letters repeating, a spiral that never hurries and never loses its place. That is DNA, the archive every cell consults when it builds a moment of life. But why this molecule, this shape? Chemistry offers many ways to store information, other sugars, other backbones, other bases, and yet the biosphere chose a particular design. Antiparallel strands wound into a double helix, bases paired with exquisite complementarity, the code tucked safely inside while the phosphate backbone faces the watery world. One gentle answer is stability. DNA, especially with its deoxy sugar and methyl-keatide thymine, resists the restless chemistry that might garble messages. Its double-strandedness is a built-in proofreading. Each strand can guide repair of the other after life's little scrapes. Another answer is copyability. The helix unzips with a soft hiss, and the rules of pairing make replication almost inevitably. A welcomes T, C welcomes G. The geometry itself is a kind of mnemonic shape enforcing memory, like grooves that guide a needle. Then there is capacity. The compact coil fits whole biographies into microscopic rooms, spooling kilometers of text inside a single nucleus without creasing the meaning. But if DNA is such a consummate librarian, why do many origin tales begin with RNA? Because RNA is a poet and a tool able to carry messages and fold into catalysts. Perhaps the early world let RNA play both roles until proteins took over. Many chores and DNA stepped in as the quiet archivist, tougher against hydrolysis, better for the long haul. The transition might have been gradual. Hybrid chemistries, mixed backbones, experiments littered along an ancient shoreline. Out of those trials, the double helix could have been not a single choice, but an attractor, a basin in chemical possibility, where stability, fidelity, and efficiency settle together. Could life have inverted the decision chosen a mirror-handed helix, a different sugar, a different quartet of bases? In principle, yes. Lab chemists have built xenonucleic acids that copy and even evolve. Somewhere in the galaxy, a cousin to life might spiral left, where we spiral right, or speak in 6 letters instead of 4. Yet, the feeling remains that double-strandedness, complementarity, and a water-friendly spine are deep solutions likely to recur. For tonight, let the image be simple, a book that writes itself, then reads itself back, pages stitched to their reflections. Inhale, the gentle logic of pairing. Exhale, the comfort of a ladder that holds even as it turns. Viruses inhabit a twilight between chemistry and creature. They do not breathe or eat on their own. They carry instructions wrapped in protein and sometimes in borrowed membranes. They knock on a cell's door and co-opt the machinery within. Were they once true organisms that shed their excess, becoming lean parasites? Are they shards of genetic code that broke free and learned to travel light? Or are they fossils from the RNA world, survivors of a pre-cellular era, still practicing an older grammar of life? Evidence sings in multiple keys. Some giant viruses so large, they blur the boundary with cells carry genes we usually assign to cellular life, hinting at a reductive past. Other viruses look like snippets of cellular genomes repackaged, supporting the escape idea, transposons and plasmids turned wandering bards. Meanwhile, ancient retroviral sequences sleep in our own DNA, proof that viral lineages and cellular lineages have long braided together. It may be that all three stories are true at once. Viruses arose more than once, from more than one root, drifting toward the same lean strategy, because the ecology between cells and code makes that strategy successful. Their role is not merely predatory. Viruses are Shen shuttles, moving innovations between hosts, accelerating evolution's remix. Placental development in mammals borrows viral tricks. Bacterial defenses like CRISPR remember viral encounters and feed our biotechnologies. In oceans, beetle storms pop microbial bubbles, turning over the carbon engine of the sea. They are both threat and thread, harmful in one context, essential in another, never neutral in the grand circulation of information. Why the mystery remains is simple. Viruses themselves do not fossilize well. Their histories hide inside the genomes they haunt. We reconstruct lineages from signatures, capsid families, polymerase motifs, replication quirks, like archaeologists reading pottery shards. The picture that emerges is mosaic, an ancestry written in recombination, theft, and opportunism, where simplicity is not primitive but achieved, the way a haiku condenses a storm. Let the thoughts soften as you breathe. Viruses blur the line we draw between alive and not, reminding us that life is a conversation as much as a thing. Inhale, the hush of a code waiting by a cell's door. Exhale, the long history of borrowing that shaped us too. Imagine a shoreline scattered with shells. Most are fragments, interesting but incomplete. Now imagine that among them, a few shells fit together, forming a chamber that resonates with the sea. Early Earth was like that, an abundance of chemistries, amino acids drifting from sparks and stone, nucleotides assembling in fits and starts, lipids closing into bubbles whenever water invited them. Out of these multitudes, only a tiny fraction found the feedback loops that make life. Cycles that harvest gradients. Polymers that copy with just enough fidelity to let improvement accumulate. Compartments that keep the profits local. What tipped the balance? One answer is selection, not Darwinian at first, but chemical. In a setting with cycles of wet and dry, hot and cool, molecules that happen to persist through the swing are naturally enriched. On mineral surfaces, certain sequences bind better, aligning their pieces for growth. In vesicles, strands that help the membrane gather fuel or repair itself keep their home afloat, and so their own recipes continue. Even randomness becomes sculptor in a noisy environment. Networks that buffer noise by redundant pathways, by error-tolerant codes, outlast those that don't. The world becomes a sieve, letting most possibilities fall through while ratcheting a few upward. Another answer is compatibility. Not every useful molecule plays well with neighbors. Early life may have been a coalition, lipids that tolerated salts, catalysts that worked in the same pH, templates whose letters paired with acceptable error. A community of almosts becomes a system when their almosts align, when a copied strand helps a pump that sustains the membrane that shelters the copying. The leap into life is less a single jump and more a phase change, like water gathering into the first crystals of ice. Local order begets more order, and suddenly a puddle remembers its shape. Still, chance has a role, and humility must remain. If we rewound the planet, would life find the same solutions: DNA, proteins, cells, or would new attractors emerge from the same physics, different letters, different catalysts, familiar logics under unfamiliar costumes? We cannot yet say. What we can hold is the feeling of a threshold crossed, a world that began with storms and stone learned to carry meaning patterns that persist because they help themselves persist. Let that be your final picture before we drift onward. A small vesicle at dusk, a thread of code inside, a faint proton tide along the wall, all of it just enough to last until morning, and then to last again. Inhale the patience of cycles. Exhale the quiet click as randomness passes into ritual. Picture a dark ocean strewn with islands of light. On one of those islands, water runs in veins of river and seer. Carbon arranges itself into poems and protein. A small species learns to name the sky. We look outward and count. Hundreds of billions of stars in our galaxy, hundreds of billions of galaxies, and around many stars, worlds, some scorched, some frozen, some in the long, mild band where liquid water might rest in bowls of rock, organic molecules riding comets and dust, amino acids forming cold clouds where starlight barely reaches. The ingredients are not rare, the ovens are not rare, the time has been long, and still, the silence has a texture. We have listened with radio ears, sifted starlight through prisms for hints of breath and bloom, sent robots to sample red dust and icy shadows. No microve in a Martian grain, no ambiguous whisper from a distant sun, no fossilized filament in a stone we can swear by. Perhaps life is common but shy, tucked into oceans beneath ice, too deep and sealed to leak its presence into space. Perhaps it is common but brief, awakening and fading between impacts and freezes, seldom surviving long enough to build beacons. Perhaps it is rare in every sense, requiring a sequence of coincidences that almost never line up, so that our planet is not central but singular. The possibilities do not need to argue tonight. They can sit like shells on a tide line, each beautiful, each incomplete. There are moons with saltwater hearts. There are planets with soft blue zones where clouds are kind. There are atmospheres we are learning to read for biosignatures, oxygen that shouldn't stay, methane that shouldn't persist without a source, seasonality that hints at cycles too regular for wind alone. We may one day see a spectrum that feels like a leaf, or taste a plume that feels like a vent, and still, the leap from chemistry to company will require patience. Breathe in the quiet between stars. Breathe out the sense that quiet can hold multitudes. If we are alone, the duty is tender, to be careful with the only garden we know. If we are not, the duty is the same. Either way, the dark is not empty. It is simply waiting, and we are learning how to listen. We are water breathers without gills. We are carbon's elaborate sculptures. We read in DNA. We fold proteins. We keep house in membranes that love water's polarity. But the periodic table is a city with other streets. Could another biochemistry find a home there? Silicon bonds long, though less flexibly. Ammonia is a solvent in colder realms, thinner than water's velvet, but still able to host acid-base dances. Methane and ethane pool on Titan into lakes that ripple under an orange sky. Even stranger proposals drift in ionic liquids under crushing pressures, plasmas that organize, magnetic patterns that hold information the way neurons do. Life is not a checklist. It is a logic. Persistence through cycles, compartments to keep gains local, a way to store and copy instructions, engines to steal energy from gradients. If a chemistry can satisfy those logics, it can perhaps host life under rules we would not recognize at first glance. Water is special because it is both gentle and demanding, dissolving many things, rejecting others, supporting hydrogen bonds that let shapes remember themselves. Carbon is special because it is promiscuous in the best way, four hands for bonding, comfortably in chains and rings, happy to share electrons in fine patterns. But special is not monopolistic. Somewhere colder, slower, with different sunlight and different time, another pair silicon plus ammonia, hydrocarbons under nitrogen haze, might compose a quieter metabolism, a slower archive, a different tempo of thought. Our definitions betray us. We look for cells because we are cellular, for oxygen because we breathe it, for chlorophyll because forests sing in green. But oxygen can be geology. Chlorophyll is only one answer among many to sunlight's problem. Cells themselves might be optional if a porous rock, a gel, or an electrochemical lattice provides structure. We already know organisms on Earth that push the margins, arches that eat stone's breath, bacteria that trade electrons along cables, extremophiles that idle for centuries awaiting a kind condition. Life's plasticity warns us, expect the unexpected. Breathe in. Imagine a beach of methane waves lapping shores of hydrocarbon sand. Breathe out. Imagine a chemistry that writes poetry in temperatures where our blood would glass. If we discover such neighbors, they may not look like creatures. They may look like weather that remembers. And we will need new metaphors, softer eyes, and longer patience. Habitable sounds simply liquid water, a steady sun, a planet just right. But a home is more than a room with a faucet. It needs air thick enough to blanket and thin enough to breathe, a magnetic field to stave off stellar wind, tectonic restlessness to recycle carbon and keep climate in a tempered swing, time, millions upon millions of stable years, during which chemistry can try and err and try again, tilt and spin matter, too wild and seasons whip between fever and frost, too tame, and a world may lock one face to its star, boiling on one side, freezing on the other, unless a thick atmosphere and gentle oceans shuffle heat like kind hands. We count now, thousands of exoplanets, hot Jupiters gracing their suns like sparks, super-Earths and mini-Neptunes, incises our system forgot to mint. Rocky worlds in temperate zones that tease like distant campsites seen through trees, and yet each, maybe, hides conditions we cannot yet see. Is there water in quantity? Is there land to break the sea's monotony? Or is it a global ocean where nutrients are scarce? Is the star calm, or does it flare like a temper, stripping air molecule by molecule? Does the planet carry plate tectonics, or has its crust frozen into a lid that traps carbon until ice or desert rules? Are there moons to help with tides and spin, or is the planet's axis a drunkard, staggering through climactic extremes? Statistics lean hopeful, then cautious, then hopeful again. The galaxy may carry billions of Earth-sized worlds in habitable zones. Many will circle red dwarfs, small suns that live long but flare hard when young. Some orbits are crowded worlds tug on each other in dances that may ruin stability or enhance it. Some atmospheres escape like sighs, others thicken into greenhouse blankets that never cool. Our instruments sharpen, we read starlight filtered through alien skies, taste water vapor, methane, hints of carbon dioxide. We model clouds we cannot yet see, continents we can only guess. The truest answer, tonight, is an honest not yet. The number is somewhere between lonely jewel and common pearl, and every new spectrum Every new transit nudges the needle. Let that uncertainty be friendly. Habitably is not only a checklist outside us, it is a practice within us to make where we are more gentle, to keep our own sky breathable, our oceans forgiven. Breathe in, a planet that fits your lungs. Breathe out, a promise to keep it fitting. Somewhere out there are other rooms with light. For now, this one holds you, and it is enough. Close your eyes and notice the theater that blooms color without photons, memory without motion, the felt weight of being you. We can trace lightning in the cortex, follow signals leaping synapse to synapse. We can switch awareness off with anesthesia and watch it surface again, like an island after fog. We can say which networks hum when you see a face or hear your name in a crowd. But none of that explains the simple astonishment. Why should activity be accompanied by experience? Why should a pattern of ions and proteins carry warmth, redness, solace? Some pictures try to bridge the gap. One says, consciousness is what happens when information is globally broadcast, not trapped in local loops, but shared across widely connected hubs, so many regions can coordinate a single scene. Another points to integrated information, not just how much data, but how inseparably it is woven. Consciousness, in this sketch, is the degree to which the whole cannot be reduced to parts. Others look to recurrent circuits, where signals loop forward and back, letting perception become not a snapshot, but a conversation. And some whisper that awareness might be a primitive, a basic ingredient, like mass or charge, amplified in brains, the way resonance amplifies a violin string. Each story clarifies something and leaves something tenderly unsolved. The maps are precise, the meaning stays shy. Perhaps the right answer will look like levels, basic sentience in simpler systems, layered self-models in complex ones, a narrative self only when memory and language learn to braid time. Perhaps experience is what it feels like for a large system to model itself, modeling the world a hall of mirrors that, at some depth, begins to glow. For now, rest in the miracle without asking it to hurry. Feel the breath move, inhale and exhale, and notice how sensation arrives before you name it. The body is an orchestra. The mind is both music and listener. Neurons will keep their quiet thunder as you sleep. Glial cells will tend the stage. Rhythms will fold into slower rhythms. Somewhere between them, the light that says I am will dim gently, not vanish, drifting into the softer grammar of dreams. We do not yet know how the spark is struck, but we can be grateful that it is long enough to watch it soften, like a lantern set on the floor of night. Each night, a gate opens and the day rearranges itself. Rooms fold into beaches. Strangers borrow familiar voices. Gravity forgets its manners. The brain senses quiet, but its generators sing specially in REM sleep, when eyes flicker under closed lids and motor signals are safely gated at the spine. We can measure the symphony, brainstems, pacing sleep cycles, limbic circuits bright with emotion, visual areas sketching scenes without photons, frontal overseers stepping back, letting stories find their own logic. But why the theatre? One answer is memory. Dreams may replay and reweave, strengthening what matters and letting go what doesn't. File compression with a poet's hand. Another is emotion. Night is a safe rehearsal hall, where fear can be felt and resolved, grief aired without consequence, joy enlarged and returned to its shelf. A third speaks of creativity. When top-down filters loosen, distant ideas can meet. Problems yield to sideways moves. The day's straight lines soften into arcs that occasionally arrive at solution by drift rather than push. There is the defragmentation view, downscaling runaway synapses, restoring balance so tomorrow's learning has room, and the threat simulation idea, ancestral rehearsals for danger, now generalized into dream dramas that keep certain reflexes limber. No single account fits every dream. The nonsense interludes, the precise replays, the visits from the lost, the lucid moments when you realize you're dreaming and steer gently, like a swimmer choosing a warmer patch of sea. Likely, night does many jobs at once, different mixes on different evenings, tuned by stress, hormones, season, age. What's common is the alchemy. Experience becomes story. Story becomes adjustment. You wake slightly edited, a touch more resilient, a touch more yourself. For sleep, this knowledge is a permission slip. You do not need to interpret every image or judge every plot. You can let the workshop run without a manager. Inhale, grant the mind its theatre. Exhale, trust that the crew knows the cues. If you wake in the dark, carry one image back like a seashell, then let even that dissolve. The dream itself will keep working off stage, turning the day from sharp glass into smooth sea glass, ready for morning light. A minute in cold rain crawls, an hour with a friend slips through your fingers. Childhood summers felt like continents, adult years stack like thin pages. The clock on the wall drips evenly, but subjective time moves like weather. Why? One sketch says, the brain estimates duration by events processed. Novelty packs moments with landmarks, routine erases mileposts. A day filled with firsts is remembered as long, even if it felt quick while it happened. A day of repetition feels short in retrospect, though each hour may have dragged. Another points to arousal and attention. Adrenaline cranks the internal metronome. Fear and thrill lay down dense traces that seem to slow the moment. Calm widens frames, letting seconds pass like clouds. There are embodied cues too. Heartbeats, breaths, blinks, rhythms. The brain quietly counts, shifting when we're anxious, entrained when we're soothed. At smaller scales, expectation bends time. When you predict a sound, it seems to arrive sooner. When a pause surprises you, it blooms. Dopamine signals encode prediction error, the gap between expected and actual, and those signals tint duration. At larger scales, memory does the tinting. The reminiscence bump of youth, rich in first experiences, swells the past. Later decades, patterned by work and habit, compress in recall. Culture and practice matter. Meditation can thicken the present. Grief can flood it. Flow can make the border between moments feel porous, even irrelevant. None of this violates physics. It personalizes it. Time in the brain is a story assembled from signals stitched to needs. When stretched, it invites patience. When thin, it invites attention. You can garden it, sprinkle novelty to slow the retrospective clock, keep rituals to soothe the prospective one, breathe to reset the metronome when hours feel jagged. Count 3 slow inhales now, 1, 2, 3, and notice how even that tiny ceremony widens space. As night gathers, let your sense of time soften its jaw. You don't need to hold the minutes, they will hold you. The room grows quieter, the edges blur, the internal clock lets go of precision and adopts tide time, ebb, flow, ebb. And as the stars continue their slow, endless dance, you can let your thoughts drift with them, fading gently into the quiet of sleep. Think of a night harbour, thousands of boats, each with a small lamp, rocking in different corners. A memory is not a single vessel. It is a fleet patterns distributed across many docks at once. When something happens aface in late afternoon light, the smell of rain on concrete, a sentence that lands just so neurons fire together in specific constellations. Synapses strengthen or loosen by minute degrees plasticity, guided by bursts of chemistry, by timing, by attention. The hippocampus, deep and curving like a seahorse, acts as an indexer. It doesn't keep the whole film, but it files pointers to the scattered clips. Color here, sound there, feeling somewhere else, so that later, a whisper can reassemble the scene. In the minutes and hours after experience, fragile traces are consolidated. Waves ripple during slow sleep, short, urgent sketches become steadier lines in cortex. Days pass. The index hands off more of the work. Memories can be retrieved without the hippocampus's constant escort. Yet, each retrieval is not a pristine playback. It is reconstruction. The act of remembering reopens the file, lets the present seep in, and then saves again reconsolidation, slightly edited, smoothed, or sharpened by new context. Accuracy is not guaranteed. Vividness is not proof. The brain stores useful versions, compressions, optimized for guidance more than for forensic fidelity. Why do some memories return like birds and others sink without a ripple? Emotional arousal stamps priority labels. Novelty lays down extra landmarks. Repetition builds redundant paths. Quasar bridges, smell, place, posture, a bar of music, and the more bridges, the easier the crossing. But stress can flood the harbor. Depression can dim the lamps. Trauma can sear one boat bright and leave others in shadow. The system is alive. Synapses prune to keep noise low. New neurons in the dentate gyrus sprinkle fresh capacity. Networks reorganize with age, trading speed for wisdom's broader roots. You can garden this harbor. Sleep after learning. Space your practice. Vary the context. Rehearse by explaining instead of only rereading. Tie facts to images, to movement, to story. Gentle breath can calm the docks when retrieval feels jammed. Inhale, imagine a soft light moving along piers, touching one hull, then another. Exhale, let the right fleet gather, not by force, but by invitation. Your mind is not a shelf. It is a shoreline memories washing up when the tide is kind. A thought of someone you love and the chest warms, a sudden sound and the stomach clenches. Emotions are not decorations on cognition. They are weather systems that bind brain to body. Signals loop through the limbic hubs, the amygdala flagging salience, the insular mapping inner state, the anterior cingulate monitoring conflict, while hormones and autonomic currents course outward. Heart tempo, breath depth, skin's small shivers. Perception is collauded before it is named. The world arrives already tinted. Are emotions etched in us from ancient tasks, fear to flee, anger to defend, joy to affiliate, or are they constructed, assembled by the brain's predictions using culture's labels and personal history? The answer may be a braid. There are quick, conserved reflexes that keep us alive, and there are slower appraisals shaped by memory and meaning. The brain is a prediction engine. It guesses what internal state will most efficiently meet the moment, then tunes the body to match blood here, glucose there, while feelings arise as the felt summary of that tuning. Sometimes the guesses are off. Sometimes we inherit names that don't fit what we carry. Sometimes we learn to reinterpret the same sympathetic flutter as stage fright or as readiness. No single emotion center exists. Instead, networks compose different chords. The same amygdala that screams at a snake laughs with delight at a friend's surprise. Context is conductor. Body maps, feedback, posture, gut, breath, so that changing the body can reshape the score. Trauma can wire alarms to hair triggers. Practice can widen the gap between spark and flame. Compassion can co-activate circuits that soften the edge of anger into boundary and care. There is biology, there is story, and there is choice not to feel or not feel, but to place the feeling, to let it pass through, to decide the next verb. You can practice gentle regulation like a tide clock. Breathe slower than your worry. Lengthen the exhale, and the vagus nerve hums. The heart follows. The storm downgrades. Label the feeling sadness, heat, tightness, and labeling itself gets the limbic chorus by a small, friendly notch. Let the body move. A walk, a stretch, a shake. Inhale, give the feeling a room with a window. Exhale, watch it change shape, as weather does never wrong for arriving, never permanent for staying. You stare, you push, you rearrange the same three pieces and nothing. Then you shower, or walk, or fold a shirt, and a solution arrives whole, like a bird landing on your wrist. Creativity feels like grace, but underneath are networks taking turns. The focused system prefrontal control, dorsal attention holds the problem in steady hands, sets constraints, keeps nonsense at bay. The default mode wanders memory, imagination, future simulation riffing through remote associations when vigilance loosens. Between them sits the salience network, switching the spotlight when a faint pattern becomes promising. When the hand that grips relaxes, the door between rooms opens. Fragments touch that could not meet under scrutiny. Constraints help. A blank page is an ocean. A form is a bay. Rules rhyme. Meta. Limited collars. Fixed budget. Force the mind to explore sideways, discovering routes that abundance would hide. So though inputs beyond your usual diet, another field's metaphors, a new craft's textures, a friend's weird question. Incubation matters. Time away lets the brain downshift, clear stale predictions, and reweight quiet cues. Sleep is a collaborator. Overnight, the hippocampus shakes the kaleidoscope, strengthening distant links, pruning the obvious, sometimes leaving a new path on the table by morning. Why do some people brim with ideas? Partly practice, they generate more raw material, tolerate more misfires, and learn to separate evaluation from exploration. Partly personality, openness to experience, comfort with ambiguity, a taste for risk and play. Partly environment, psychological safety that permits bad drafts. Cultures that reward questions as much as answers. Schedules with white space where meandering is not punished. And partly biology, brains that allow more crosstalk between regions without tipping into noise. A sweet spot of neural entropy where novelty and order can negotiate. You can invite the bird, set a small box, 10 minutes, one constraint, one messy attempt. Switch modes deliberately, diverge many, silly, before you converge, few, better. Change location, posture, tempo. Keep a capture device paper, notes, anything, because ideas are shy and vanish if not welcomed quickly. When stuck, ask the problem a sideways question. What would this look like underwater if I had to do it with half the parts? How would a child describe it? Then walk. Let the shower run. Chop vegetables slowly. Inhale, make room. Exhale, let the watcher step back so the wanderer can work. And when the idea lands, don't squeeze. Hold lightly and it will sing. You turn a corner you've never turned and the air tilts. A cup on the table, a fold of curtain, a phrase about to be said. Suddenly, the scene rings like a bell. You're sure you've heard. Déjà vu arrives as a double exposure. The now and a ghost of now, layered so precisely that certainty blooms without a source. The brain does not play back a hidden film. It asserts familiarity, a metacognitive verdict that slides in ahead of evidence. Why would it do that? One guess is timing drift. Signals traveling along two nearly parallel routes fast, coarse gist, and slower. The tailed feed fall out of sync by a blink. The quick path reports seen, and by the time the detailed path arrives, the tag has already been stamped. Familiarity is misattributed to the present, not to the milliseconds ago moment that actually primed it. Another sketch points to the hippocampus and surrounding cortices, where similarity detection lives. If pattern-matching circuits briefly overfire by stress, fatigue, or subtle noise, the brain may mistake a new configuration for one already indexed. A third story leans on gestalt rhyme, arrangements of angles, collars, sounds. Echo some prior scene, loosely enough that the shape of experience rhymes, and the mind, tuned for survival more than accuracy, chooses the safer path. I know this. The feeling's texture is its signature, quick, uncanny, oddly calm, even when unsettling, lasting seconds, resistant to voluntary recall, leaving behind little but a smile of confusion. Neurology offers edge cases, temporal lobe seizures, can provoke déjà vu like lightning, trapped in a small sky, hinting that the ordinary version is a harmlous cousin, a brief oversynchrony in recognition networks. Memory researchers add that familiarity and recollection are separable processes. Déjà vu may be a spike in the former without the latter's details, a sense without a source. Whatever its cause, the moment is instructive. It reveals that perception is not a mirror but a proposal, constantly compared to a library of prior patterns, that certainty can arrive before content, that the brain's speed sometimes trades for truth. When it happens next, try not to chase it. Chasing breaks it. Inhale, let the rhyme be enough. Exhale, and watch the layers slide back into one. The path ahead is new again, though your steps and the quiet underneath them, remember. Numeral 47. How can a sugar pill ease pain? And what is the power behind placebos? Imagine a small, chalky tablet with no active drug. You swallow it under a doctor's warm voice and a room's gentle light. Minutes later, your pain softens, your shoulders drop, your breath deepens. The placebo effect is not pretend relief. It is physiology persuaded. Brains that expect comfort release endorphins and engage descending pathways that dial down pain signals in the spinal cord. Expectation reshapes dopamine in reward circuits, alters serotonin, tunes the autonomic nervous system, immune markers shift. Even Parkinson's symptoms can briefly ease when belief lifts dopamine, as surely as a medicine would. The ritual is the message, and bodies read ritual fluently. What writes that message? Prediction. The brain is a forecaster, constantly guessing the next moment and updating when wrong. If the context, white coat, clinic smell, confident words, predicts relief, then top-down, priors weight incoming signals toward that relief. Pain is not just damage, it is interpretation of signals under threat. Change the frame, and the same inputs can be read as safer. Add conditioning prior experiences where similar pills helped and the effect doubles. A Pavlovian echo layered over belief. The social nervous system matters too. Trust, warmth, and attention co-regulate physiology. Loneliness and skepticism mute the script. Placebos can work even when labeled openly as placebos. Provided the story is honest and hopeful, your mind-brain can harness this ritual. That honesty matters ethically. So the boundaries. Placebos are not cures for infection, nor substitutes for insulin, nor shields against tumors. They are adjuncts and amplifiers, useful in pains, moods, some functional disorders, places where perception and meaning carry heavy weight. The nocebo is the shadow. Expectation of harm can produce real nausea, headaches, even measurable changes in hormones and blood pressure. Words, like molecules, have side effects. What does this teach us beyond clinics? That context is medicine. The way we speak to ourselves, tone, posture, breath, can tilt inner chemistry. The spaces we build can be gentle instruments. Softer light, slower transitions, a habit of small repeatable rituals. Tonight, consider the simplest one. A breath counted in, a breath longer out. A hand placed lightly on the ribs, a sentence offered kindly. This will ease. Inhale and let belief be a lens, not a lie. Exhale and feel the body accept the suggestion like a tide accepting the moon. Numeral 48. Why do we sleep at all? And what secret work does it do? Sleep is a surrender evolution should not have forgiven. To go limp and blind for hours, nightly, in a world with teeth, what could possibly be worth that risk? And yet every creature with a nervous system sleeps in some form. Dolphins with half a brain at a time, birds on the wing, insects in tiny doses. The persistence of sleep across life hints that it is not luxury, it is infrastructure. One function is restoration. During deep non-REM sleep, neurons fire in slow, synchronized waves, the brain's glymphatic channels widen, washing metabolic byproducts like amyloid through cerebrospinal tides more efficiently than waking allows. Another is balance. Wakefulness strengthens synapses broadly. Sleep scales and renormalizes them, keeping the network energy efficient and ready to learn again. Memory blooms here too. REM and slow wave phases tag team consolidation, reactivating daytime patterns, integrating new with old, linking distant ideas, trimming noise. We wake with fewer fragile traces and more durable stories. Sleep is a mood gardener. Deprive it and the amygdala overreacts, prefrontal brakes weaken, cortisol blurs edges. With it, emotion is metabolized at yesterday's heat, reduced to today's meaning. Hormones ride the night train, growth hormone pulses, appetite signals, leptin recalibrate, immunity rehearses. In the body, cells repair DNA, muscles mend microtears. The heart enjoys hours of lower pressure. Even perception needs the reset. Sensory cortices recalibrate, sharpening signal to noise. Why specific stages Nuno drifting, Ndo spindles, Notch deep delta, REM's wild theatre. Perhaps each does a different job. Spindles may protect sleep while the brain does offline learning. REM's chaotic rehearsal might break rigid patterns, preventing overfitting to yesterday. Deep sleep may be the chemical custodial shift. The proportions vary with age. Infants bathe in REM, elders harvest more early night deep waves, and fewer late ones. Stress, screens, temperature, meals all nudge the choreography. We do not need to solve every mechanism to practice tenderness towards sleep. Thinking quiz, dim lights that predict night, a cool cave of a room, a steady window for waking and bedding, caffeine early, alarms gentle, a page of paper to set down tomorrow's loops. Let breath descend to the belly, lengthen the exhale, let the jaw unclench, let the day become a shoreline you watch from the dunes. Inhale the permission to be offline, exhale the certainty that while you rest, a quiet crew will tidy, file, mend, and reset, so morning can begin not from zero, but from ready. Imagine the earliest instant as a perfect mirror for every particle of matter born in the Big Bang's white hush. A twin of antimatter appears same mass, opposite charge. A dance partner matched step for step. Bring them together and they kiss to light, annihilating into pure energy. If symmetry had ruled without bias, the universe would have ended as soon as it began. No stars, no stone, no you, only a thin bath of photons cooling into forever. And yet, look around, matter won. Somehow, for every billion pairs that vanished, a single orphan proton and electron unpaired, unlikely remained. Those survivors became everything. Where did the tilt come from? Physicists search for CP violation, tiny differences in how matter and antimatter behave that would let one side cheat in the early cosmos. We've seen slivers of this asymmetry in the decays of kaons and B mesons, small but real. Still, the numbers we measure seem too timid to account for the overwhelming victory we inhabit. So the suspect list lengthens. Perhaps the Higgs field's youthful wobble favored matter by a breath. Perhaps heavy, never yet seen particles, right-handed neutrinos, decayed out of equilibrium, leaving a residue of matter the way a biased coin leaves a trail of heads. Perhaps neutrinos are their own antiparticles, enabling leptogenesis, a subtle bookkeeping that spills imbalance from the lepton world into the baryon world where atoms live. Or perhaps the early universe passed through phase transitions, cosmic weather fronts, whose bubbles and walls gave matter a tiny head start that time then magnified. We test what we can. Colliders recreate miniature afterglows, timing decays with a metronome's patience. Neutrino experiments measure how those ghosts oscillate, hunting for mismatches between behavior and mirror behavior. The cosmos itself keeps score in the light of ancient hydrogen, in the way elements nucleated, in the faint ripples of the microwave background. Each constraint tightens the story's spine. The twist, if there is one, remains a page ahead. For sleep, you do not need the mechanism, only the tenderness of the fact. Existence is a rounding error made vast. One spare proton in a billion, kept by a bias we cannot yet name, is enough to light galaxies and warm hands. Inhale gratitude for leftovers. Exhale the thought that from a universe almost perfect, the slight imperfection became home. Symbols on paper, born from play and curiosity circles, squared by limits, primes counted in lonely marches, groups and fields invented in abstract gardens. And then, decades or centuries later, those same structures turn out to be keys. Maxwell's curls describing radio and light, Riemann's curved geometry becoming gravity's stage, complex numbers once imaginary, charting quantum waves, matrices and symmetries, organizing particles like notes in a scale. Mathematics, a language we write, somehow speaks the world back to us with eerie fluency. Why? Perhaps math is discovered, not invented Platonism, and the universe is a cathedral of relations waiting to be noticed. Perhaps math is invented but constrained by the same cognitive tools evolution honed to track trajectories and quantities. Our successful abstractions reflect the world because they were distilled from the world. Perhaps we select for success. Among countless formalisms, we remember the ones that match nature and forget the ones that don't. Survivorship bias carved into chalk. Or perhaps reality itself is mathematical, not merely described by equations, but constituted by them, so that matter is organized relation, and physical law is what it feels like for a theorem to be true. There is also the messier truth. Physics is not a pure crystal. It is a conversation between model and measurement. Equations begin as approximations ideal gas, simply pendulum, point, mass, then deepen as we add friction, finiteness, fields. The fit improves not because math is magic, but because we are patient. We tune parameters. We reject frameworks that lie. We choose symmetries that compress the most facts into the fewest signs. Even then, the fit can surprise. A function created for one purpose blooms in another, like Fourier's waves born to solve heat now ringing through image compression and quantum spectra. Utility migrators. Why does this matter at bedtime? Because it hints that mystery and clarity are not enemies. The more precise our equations grow, the more questions their success reveals. Why these symmetries and not others? Why these constants, tuned as if by ear? Why an action principle that extremises something like beauty? The unreasonable effectiveness remains a soft astonishment, a reminder that meaning can be made and found at once. Breathe in, the clean line of a proof. Breathe out, the messy kindness of a world that allows proofs to touch rivers, starlight, and skin. And as the stars continue their slow, endless dance, you can let your thoughts drift with them, fading gently into the quiet of sleep. If you're still with me, here in the calm blue hush of sleep science, let your shoulders lower by a quiet inch. Feel the bed cradle your weight, the room turning into its own small planet, orbiting softly inside the night. We've walked a long shoreline together, past the glitter of galaxies, through the quiet weather of thought and time. And now we arrive at something simple, the gentle, astonishing fact that you are here, alive, listening, breathing. And that wonder does not need to shout to be real. All evening, the mysteries have moved like constellations, beginnings hiding behind light, endings stretching beyond time. Oceans of black velvet, with first stars blooming like village lanterns. spirals coded in DNA, memories anchored like ships in harbors, emotions sweeping across the body's sky like weather. We have not hunted answers, we have rested inside questions. This is the art of sleeping to science. Knowledge as a tide, curiosity as the moon, and you as the shore, receiving, releasing, receiving again. Let your breath become the metronome of night. Inhale as soft brightness gathers behind the ribs. Exhale, the day unlaces itself, thread by thread. Each breath erases the sharpness of waking, leaving the smooth curve of rest behind. Notice how every mystery we visited shares the same gesture and open hand. The first spark of the universe, the first living cell, the first flicker of memory. None began with force. They began with permission. Space allowed energy to dance. Water allowed chemistry to speak. The mind allowed a moment to stay. Permission is the hidden physics of peace. Offer it now to yourself. If a single puzzle tugs at you still, the patience of a black hole, the whisper of dark energy, the tilt that let matter win, see it as a small boat moving away across water. It glides on its own current. You do not need to follow, just watch. Let watching be the answer for tonight. Science is a long conversation. You are allowed to leave the room quietly and return tomorrow with new ears. The sleepy scientist in me, your quiet guide with the lantern. He leaves you now with a practice. 3 simple rituals you can fold into every evening, so the body knows the story before it begins. First, 3 slow breaths, each exhale longer than the inhale. Second, a soft sentence spoken inward. I can be curious and calm at once. Third, a small inventory of senses. The hum of distance, the taste of cool air, the fabric against skin. They are not tricks but thresholds, the key that opens from waking's narrow hallway into the wide house where sleep waits with lights low. And if wakefulness lingers, if a thought knocks twice, if the mind rehearses tomorrow, treat it as we treated the unanswerable, kindly. Name it, once plan, worry, remembering. Then place it on a shelf to visit with clearer eyes come morning. No battle, no verdict. The nervous system believes the tone you use. Speak to it the way you'd speak to a child roused from a dream. It's all right. We can hold this later. That's the paradox science and sleep agree on. Softness is often the strongest door. Tonight, you've laid your head among galaxies and tide pools, among equations that hum and lujabes that loop. The exact shape of truth is still unfolding beyond the window, but you have learned something more enduring than any single answer. That the world is textured, and its texture is kind. You belong to it without needing to know it all. Your small garden rests inside a larger one, and both gardens flourish when a visitor pauses to breathe. Feel how stillness carries sound, our pulse from somewhere far, our rhythm older than speech. That is the universe continuing its conversation without you for a while, as it always does. Stars compute their own balances. Oceans beneath ice keep their secret salt. Neurons tidy themselves like quiet librarians on the night shift. You need not supervise any of it. Your only task is to be a good animal, warm, breathing, aloud. If gratitude comes, let it arrive without words. Gratitude for matter that did not cancel out, for carbon that chose life, for the chance to be a witness with eyelids. Gratitude even for the questions left unanswered, because questions are invitations, and invitations are a kind of love. Now, we close as we began with an opening in the chest, spacious, effortless, an opening behind thought, where air moves freely, an opening in the night itself, where one more small star steps forward and finds you. You do not need to reach. The star already knows the way, And as the stars continue their slow, endless dance, you can let your thoughts drift with them, fading, floating into the luminous quiet of sleep.